Imagine running a company where you don't have to talk to your employees. You just give them a number and you get them addicted to getting higher numbers. And you can control them or you can test them by changing the number that they can see by controlling the statistics. So, I don't know. I can't help if I stutter sometimes. It just happens. Anyways, yesterday was the 24th. Let's see. Yeah, today is the 26th. So yesterday was the 25th. I don't even need the views. If anything, I'm pointing this out so they stop giving me views because I don't give a fuck. But I think it's funny how they play with the numbers. So I want to point out whatever. So yesterday was the 25th. Today is the 26th. Yesterday, they had the stats from the day before. Today, they don't have the stats from the day before. So I'm gonna refresh, see if it changes. Duplicate. And it still is what it was. Okay, so right now the stats show the 24th, but today is 26th. So for some reason, they held out on a day of stats. They didn't do that yesterday. Yesterday, the stats on the 23rd said I only had 62 whatever traffic, whatever that means. Yesterday was the 23rd. I go over here. Yesterday, it says I had 0, 1, 2, 3, 1, 2, 3, whatever. But it says 62 here, right? If I go to my videos, this is why I didn't look at the videos at the start, but now I'm kind of looking. They're playing games with the numbers because their employees are people looking to be famous, hoping to get noticed, and it's all just a game. It's just ridiculous. I don't need money from YouTube. I'm gonna make money from the JavaScript engine. So the last video I did, it says, how does it still say live? Oh, it's live now. Last video, whatever, it says only 59 views. Okay? 59 views. But yesterday, this video had 54 views, I guess. So yesterday I had 54 views, and what's this one? I think it's Abysmal. 35. Wow, that jumped. It said 9 an hour ago. And this is me complaining. This was yesterday. They showed the stats from the day before, but today they don't show the stats from yesterday. They're hiding them on purpose because there was a jump in the stats here and they don't want to show it. But somehow, the day before, yesterday, which is '26, '25, '24. Here. So this is yesterday. Yesterday. It says I have 124 views. Does this video here with 35, this video only 54 views? That's 54. This is only 35. So that somehow equates to 124 views. Okay? Now this is my point. On the 22nd, it says 204 views. But it only says 54 views. It's not even clicking. It's only 119 and 54 views. I don't know. These stats are complete bullshit. And they totally play with the numbers. And they have people hooked on getting attention for free. They don't have to individually contact people. They have free employees looking to get famous, and they control them by playing with these numbers and playing psychological mind games. It's really obvious that's what's going on. Because the day before is 124, which is 100 less than 204. And it's going up. And I got a subscriber. Everything's going up, but the stats kind of stop. Because I gotta wait. Because this only has 35 views. I don't know. This is so fake. They're totally playing with these numbers. They're testing to see if I have constant traffic, if there's a dip, if I'm going to keep streaming. And someone at YouTube is watching my channel because people get paid. There's no algorithm. I don't know. I think it's kind of lame. Social media. They get free people working. They play psychological mind games. And they expect it to work on people. So, YouTube, whoever's watching me, don't give me traffic because I don't give a fuck. I'm not going to get paid. Oh, look at this. Now it bounced. Now I have 10 viewers. All of a sudden, out of nowhere? Huh, that's a little weird. This is a joke. Social media? I don't know. I'm not buying it. But you guys, all of you, can buy my JavaScript engine because I don't care what the fuck YouTube has to say, whatever they want to do. They can play games, but I can play games too. So, okay. This is ridiculous. Oh look, now it's 13. That's really odd. It's really strange. These statistics are bullshit. And giving me, now it's 14? Are you kidding me? You guys are ridiculous. You can suck my dick. Anyways, YouTube can suck it. But I want to thank YouTube for proving my point. Bunch of narcissists. Anyways, you can buy in to YouTube or whatever. Man, the mouse isn't working. Or you can buy my JavaScript engine when it's done. I'm running a JavaScript engine. It's gonna be a big ass deal. It's gonna be the fastest JavaScript implementation since JavaScript, because I'm writing a majority of it in assembly language, and I'm streaming the whole thing on YouTube. So YouTube might play with the views, but okay, I don't care that much. I'm kind of joking when I say they can suck it. I don't know. It's fun. Anyways, it's all just a game, except this isn't a game. I am writing a JavaScript engine. It has been made, designed for video gaming, because if I can find PDF. Unlike the modern JavaScript engine, which is virtualized, I'm writing my JavaScript engine entirely in C language, because I need to be cross-platform, but parts of it I'm writing assembly. And since I'm writing parts of it in assembly, this is going to give me a big edge over virtualization. The current JavaScript implementation it doesn't support MMX, SSE, SSE2, SSE3, SSSE3, SSE 4.1, SSE 4.2, AES, C, AVX, AVX2, FMA3, FMA4, AVX 512, AVX 512DQ, AVX 512VL. It doesn't support all of the extended multiple instruction, data, whatever you call it. Because the modern JavaScript engine is virtualized. In the modern JavaScript engine and the modern JavaScript documentation as word leak. And as it says in the modern JavaScript implementation, is Siri not working? Really?
Weak map is unlikely to be collected and could leak memory resources in implementations.
So, the current JavaScript implementation has bugs and could leak memory resources. And they're stating here that the documentation has faulty mechanisms, but they do rebuttal this later on. They say,
Weak map and weak set are intended to provide mechanisms for dynamically associating state with an object or symbol in a manner that does not leak memory resources if, in the absence of the weak map or weak set instance, the object or symbol otherwise became inaccessible and subject to resource reclamation by the implementation's garbage collection mechanisms.
So, I'm not going to have these issues because I'm writing my JavaScript engine from scratch, and I'm going all the way down to the assembly language, and I'm live streaming it because nobody would believe me otherwise. And I'm going to make a lot of money. And if YouTube wants to play nice, then I guess they can make money too when I sell this thing. But I'm a couple months away. Hopefully, a couple months away. I don't know, I'm going to stream the whole thing. You can't see half the code, but some of the code I can show. But anyways, inside of this description about memory leaks, this documentation, the ECMA 2024, they state 2 mechanisms to deal with this memory leak issue that current JavaScript implementations have.
The following references describe mechanism that may be useful to implementations of weak map and weak set.
So the year is 2024. And these references to deal with mechanisms, how to handle these memory leaks, are from 1997. In 2008. If it'll highlight. Almost there. It's almost highlighted. There it is. 2008. So, they say
Weak map and weak set are intended to provide mechanisms for dynamically associating state.
So, if it was about intentions,
Intended.
then wouldn't they have intended to read their own sources and fix whatever mechanism that's broken in this documentation so things to
Not leak memory resources.
and
If
the JavaScript engine leaks memory resources because they followed this 2024 documentation.
'15th edition, June 2024.
Was it really their intention to give a crap when writing this documentation? I don't think that was their intention. So the 2009 documentation.
'5th edition, December 2009.
It doesn't have the word leak. If I go up here and look for the word leak, there's 0 matches. You know why? It's either because the
5th edition, December 2009.
it doesn't have memory leaks, or it has memory leaks, but they didn't realize it. I'm thinking it's a prior case, not the later. I think at some point people got lazy and they're like, memory leaks, it's fine. Computers have gigabytes of memory. And back then, it may not have broken mechanisms. So I don't know. Either way, I'm going to be meeting the 2009 standard first. Because the 2009 standard is only 241 pages. It's a lot easier to meet and like set up the mechanisms as defined in the 2009 standard. So then after that, I'm going to go through the 2024 standard, which is 804 pages. And somewhere in the newer standard, memory leaks occur. So I'm going to meet the older standard first because it's 200 pages and it possibly doesn't have memory leaks. And then when I go through 2024 standard, I'm going to update whatever was from the 200 page standard because it has to apply in some way to the 800 page standard. And I'll carefully read through this standard. Most of it will be the same. I'll like make sure there's no leaks or whatever. Because my engine's not like the other engines. Mine's I'm writing it directly for hardware. At a C level. So this is assembly language, whatever, right now. Okay, 90% of these streams are going to be very boring, but that doesn't matter. It's not for the views. It's for the process to stream it because nobody is going to believe me. Because who would? So that's why I'm streaming it. But I'm going to make a separate playlist. I have assembly to like, I have to get my feet wet to figure out 64-bit processing. It's really not 64-bit, it's 32-bit with like a tweak. I won't get into it, but it's a whole different field or whatever. So I'm trying to like wrap my head around it. And I kind of have an idea of how it's like sort of laid out. So like, unlike the current JavaScript implementation, I'm gonna, this whole thing, whatever, is being written in C with inline assembly. So it should run on any processor. And then I'm writing inline assembly for x86 underscore 64. So that PC, desktop, whatever, and also for ARM 64. And I have to figure out how to like map the functions as binary blobs and how it relates to the address space, whatever. That's what I'm trying to figure out now, whatever. I already have part of the engine, except for control flow and function calls. Because this was like, for me, whatever, this engine is like a challenge or whatever, because I pushed the browser to the limit. I had to like write my own stuff. So like now, this is like 7 years ago. So now I'm like updating it. I'm gonna release it because I have other things I could sell, but this is like the big one. So I'm gonna sell this whatever. Except since I don't have function calls in my engine, I don't use the evaluate. But when I meet this standard, the 2024 standard, even the 2009 standard, these standards, whatever, they state that to meet the standard, you need to support eval, which means that my engine is going to need to like support runtime compilation, and I can't link to the linker or like dynamically execute code because that's really slow. So I need to make binary blobs and execute them. And I realized that there's only a 2 GB space in 64-bit mode. Earlier today, whatever. It says medium code, less than 2 gigs. And it says that full 64-bit addressing is 15 to 30% slower. So basically, 64-bit processors, they run in 32-bit mode. So it says they're within 4 gigabytes. They get optimized to 32-bit values, 0 extended, because it's more compact. I'm trying to find a second. Okay, here it is. So most programs are the small model, which is RIP addressing, and it's fastest because it doesn't use the 64-bit addressing. It uses code and data less than 2 gigabytes from wherever the position is of the program. And when you get down to medium and large programs, the code gets 15 to 30% slower, which is like dramatically slower, which is why on x86 64 they push for using this mode. I don't know if you can even use this mode or this mode without like special OS access. So like everybody uses this mode or whatever. So I don't know. I'm like digging into it. So now when I get to like actually implementing it, now I know that I have 2 gigabytes is my range or whatever from the base of the program. 32-bit. It was possible to allocate like 3.5 gigs, but in 64-bit, apparently I can only get 2 gigs. But that might be a good thing, because now I could like map the smaller functions that are generated at runtime compiled, because I'm not virtualizing it. I'm going to be using the C compiler, so it's be really fast C speed code. But since it's only 2 gigs, I could map functions to the 2 gigabyte area and use RIP addressing. And the bigger functions, they'd have to go above the 2 gigabyte. For the small functions, they'd be really fast. But it also gives protection against memory injections, because I can allocate enough memory and remap things and move them around to prevent hacking and stuff. Because if I'm going to sell this thing, people aren't going to hack it, so I'm going to have to protect myself and make sure the program's safe and secure and doesn't leak memory. So I don't know. You don't have to believe a single thing that I say, and it really doesn't matter. Just like YouTube, it doesn't matter if they give me views, but there might be a benefit to it. Who knows? But I am doing this, so like when I'm done, I guess you can judge then. Or you can judge before. You can judge in general, because I really don't give a fuck. Because nobody else is going to do this. And if they do, good luck. Like, good luck. Anyways, I have like techniques, whatever, that I've learned to like, I can't even say it because then people like copy me. So I don't know. You don't have to believe me because I don't care. But when it's done. I'll release it. That's proof. So I don't know. That's about the summary. So right now, I have I'm trying to figure out 64-bit assembly and x86. I still have to figure out assembly for 64-bit ARM, and then Mac, the new Macs, whatever. They apparently have ARM64, and Chatbot said that it's the same exact CPU instruction set.
Do the Apple Silicon CPUs use the same ARM ESA as the phones? Tick direct answer. Yes. Apple Silicon CPUs, like M1, M2, M3, use the same ARM ESA family as iPhones, specifically the ARM8A and ARM9A architecture profiles, but with major differences in implementation, extensions, and performance tuning.
So whatever the new ARM Cortex is, I think that's a phone. That's not even the desktop. The M1, M2, M3, and 4, whatever it is. I gotta get a Mac at some point. But I'm gonna like treat it as the same importance as x86, and because the Mac actually gets really good performance. I kind of like don't like Apple because some of the new stuff, but I don't know. If Apple wants to play along, it'd be cool because their CPU is actually really good. It's got a bigger data bus. It's like twice the power of x86. So I don't know. First though, I'm gonna like set things up for x86. I'm gonna get in our CPU, whatever. So I don't know. I got like a whole bunch of stuff. I don't know. I think I covered everything. So I guess that's my overly dramatic intro. And now things will be very, very boring. So like right now, whatever. I'm like fighting with 64-bit mode because it's restricted and you lose the upper 32 bits of a 64-bit value when you do a 32-bit load. And there's always like funky little workarounds or whatever. But anyways, right now I have a window and I can pick between printing binary or hexadecimal. I picked the wrong freaking window file thing. I have an error. I forgot. We'll build now. There we go. So right now I have a printing binary. And this is like a list of items and has a length. And I'm like getting the base offset, multiplying it by the item, adding the offset. Really, it's not exciting. But if you want to copy me or learn assembly, then you can watch the streams and you learn something. Most people won't find this exciting. The only exciting thing is when you run the program, you're like, wow, this is so much better than the old program. Which is like my whole point of writing a new JavaScript engine. So what I can do, that was binary. I can toggle it to hexadecimal as a word or whatever. And I hit build or whatever. So I can delete the output. So NASM, the assembler, it's like a really good x86 assembler. It makes the output file here, which is an object file. And then Visual Studio links and makes the executable. So now the executable is made. And then now it's hexadecimal numbers, whatever. But it's not printing because I'm in the middle of updating it. I'm updating it to make multiple like modules of lists because I have assembly language to speed test. So Visual Studio, the Microsoft Visual Studio, it generates code at the highest optimization level that looks like this. Microsoft Visual Studio, it generates code. C language, the C compiler, to an assembly instruction that takes, or routine, whatever, it takes 26 instructions. And Visual Studio is designed by Microsoft, the people that made Microsoft Windows 11. And this is the output that it makes for converting C to assembly. This is why I'm going to be writing part of my engine in assembly, because the C compilers are limited. I'm not writing a full assembler, but I'm going to replace bottlenecks with assembly. So this is what Visual Studio makes. It's going to run at least twice as slow as what GNU makes. It's Clang, I think. I don't know, they're all the same thing. So Clang can output the same, or create the same machine code in 12 instructions compared to Microsoft with 26 instructions. I don't like the conditional moves because they're kind of slow, but it should still be faster overall than Microsoft because it's twice as big. And you might think, why does that matter? It's because the CPU that you pay thousands of dollars for, it runs, right? So when you're running Microsoft Visual Studio, your CPU executes these codes. Not only is it wasting trees, it's wasting electricity, and it's wasting your time because it takes twice as long to execute as the Clang output. So you pay however much money for the newest i9, i7, Ryzen CPU, and it runs, and the CPU's I'm multi-threading, I'm trying to load things in real time, I'm trying to get work done. And the CPU's Microsoft, why are you giving me all this unneeded bloat? So your CPU wastes time eating up instruction cycles, running at suboptimal performance using the compiler developed by Microsoft that made Windows 11. I don't know. I have something against things that suck in Microsoft Visual Studio. It sucks really bad. It really sucks. So I don't know. I think my code that I wrote for this, whatever this was, I don't know, it was a day ago. I think it was 14 instructions. So it was close to the same number of instructions. I don't know. Basically though, I'm writing a assembly language. I'm not using JIT or virtualization for my JavaScript engine. I'm keeping it in C in assembly language. I'm going to write for 64-bit x86 desktop and 64-bit ARM, so that includes the newest whatever ARM CPUs for the desktop that are actually twice as powerful as x86. The M1, M2, M3, I think M4, I don't know, whatever it is. I still gotta get my hands on one. But when I do, I'm gonna dig in to the assembly. I'm gonna like write everything, well, most of it, not all of it, the bottlenecks in assembly language. So I don't know. That's my boring stream. So I'm just like streaming the process. So whenever I get to the actual documentation, I still have to convert the engine I have to 64-bit. When I get to the actual documentation, I'm ready to release it, or when I release it. Since I'm live streaming the whole thing, I don't have to document as much because it's all on stream. So whenever I actually get to the documentation, right now I have like a prison countdown. And it looks like ghetto. It's on purpose because I don't know when. Hopefully soon, maybe days, I'm gonna get to this. But inside of the documentation, it says like the switch statement. So I'm gonna label the stream 14.2 the switch statement. And I'm gonna like time mark. And as I like write the code and I meet the standard, it's evidence that it meets the standard. So I'm gonna go through page 1 all the way down. Page 1 all the way to page 804. I'm going to document the whole thing. I have it as video evidence that I meet the standard and everything, whatever. I'm still going to have paperwork standard, and I have to add code for browser extensions. Except this is going to be the fastest JavaScript engine implementation. Or at least I would assume it would be. I really don't want to talk it up too much because then it's not going to be as like impressive. So I'm going to have to like sandbag and like stop talking it up. So I'm going to go back to like being really bored because it is very boring writing code. And it seems very, very endless. It seems very much like a prison countdown. So, like I said, however long ago, I'm working on adjusting the code I have here to print different data types, whatever. I'm putting that in a macro so I can make modules and I can print different values. So I want to print the output to make sure the macros work. And I want to print the real time that it took to complete. And I'm going to print the cycle time, how many cycles it took to complete. And I'll be able to know which code's faster. When I speed test the Visual Studio versus the Clang versus my assembly. And then that will kind of be like proof that like I can write assembly, whatever. So I don't know. That's the plan. That's what I'm gonna get to. And I guess I'll stop complaining about YouTube because I'm not a big baby. I just want to point it out. But I like being a big baby, just like everybody else likes playing the victim. It's fun to play the victim. Unless you're actually the victim, then it's like, it's no fun. So I'm gonna stop making myself the victim because I don't really care. I just want a reaction that's close enough, whatever. So I'm gonna like get back to work in a minute. I have to like macrotize the stuff, make modules. I need to print the address, a bunch of really, really boring stuff. Unless you're into programming, you want to learn something, you might learn something, maybe you won't. It all depends. And if you're watching the stream, you should stop watching the stream and you should go live your life, because you shouldn't watch somebody else live their life when you could be living your own life, doing your own stuff. So like, stop watching the stream and go live your life. If you are gonna watch stream, watch back later, because then you could like fast forward, because 90% of this is gonna be extremely, very boring, like really boring, like extremely, really boring. So this part's gonna be boring because I'm gonna take a break. I don't know. I'll be RB. I have to get Siri reading the documentation. Dang it, it's not working. I have to restart the computer. It'll take a second. Technology, it's ridiculous. Any minute now. Just switch to here for a second. How long could this take to restart? Oh, I think it hits shutdown, not restart. It's restarting. Any second now. There it is. It's dizzy. Right now it's working. So I'm gonna have Siri read the standard, the JavaScript standard, and I don't know. I want to thank YouTube for playing along. I'll stop complaining now. I guess we're cool. So I don't know. Alright, I'll let Siri read the standard then, and I'll be right back.
Cal function floor, x, yields the largest integer, closest to positive infinity that is not larger than x. Note floor, x, equals x modulo 1. If an algorithm is defined to throw an exception, execution of the algorithm is terminated and no result is returned. The calling algorithms are also terminated until an algorithm step is reached that explicitly deals with the exception, using terminology such as if an exception was thrown. Once such an algorithm step has been encountered, the exception is no longer considered to have occurred. Source text. ECMAScript source text is represented as a sequence of characters in the Unicode character encoding, version 3.0 or later. The text is expected to have been normalized to Unicode normalized form C. Canonical 2. Copyright sign, ECMA International 2009. Composition, as described in the Unicode Technical Report number 15. Conforming ECMAScript implementations are not required to perform any normalization of text, or behave as though they were performing normalization of text themselves. ECMAScript source text is assumed to be a sequence of 16-bit code.
Oh no, I'll be right back.
Such a source text may include sequences of 16-bit code units that are not valid UTF-16 character encodings. If an actual source text is encoded in a form other than 16-bit code units, it must be processed as if it was first convert to UTF-16 source character. Any Unicode code unit. Throughout the rest of this document, the phrase code unit and the word character will be used to refer to a 16-bit unsigned value used to represent a single 16-bit unit of text. The phrase Unicode character will be used to refer to the abstract linguistic or typographical unit represented by a single Unicode scalar value, which may be longer than 16 bits and thus may be represented by more than one code unit. The phrase code point refers to such a Unicode scalar value. Unicode character only refers to entities represented by single Unicode scalar values. The components of a combining character sequence are still individual Unicode characters. Even though a user might think of the whole sequence as a single character, in string literals, regular expression literals, and identifiers, any character, code unit, may also be expressed as a Unicode escape sequence consisting of 6 characters, namely U plus 4 hexadecimal digits. Within a comment, such an escape sequence is effectively ignored as part of the comment. Within a string literal or regular expression literal, the Unicode escape sequence contributes 1 character to the value of the literal. Within an identifier, the escape sequence contributes 1 character to the identifier. Note, although this document sometimes refers to a transformation between a character within a string and the 16-bit unsigned integer that is the code unit of that character, there is actually no transformation because a character within a string is actually represented using that 16-bit unsigned value. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000, for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode character 000A is line feed, and therefore the next character is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, A Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes a character to the string value of the literal and is never interpreted as a line terminator or as a quote mark that might terminate the string. Literal lexical conventions. The source text of an ECMAScript program is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of characters as the next input element. There are two goal symbols for the lexical grammar. The input element of symbol is used in those syntactic grammar contexts where a leading division or division assignment equals operator is permitted. The input element regexp symbol is used in other syntactic grammar contexts. Note there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 7.9, in examples such as the following: a equals b high g exec, c map, d, where the first non-white space, non-comment character after a line terminator is slash, comma, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as a equals b high g exec, c map, d, ECMA International 2009-13. Syntax: input element of white space, line terminator, comment, token div punctuator, input element regexp, white space, line terminator, comment, token, regular expression literal. Point 1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher-level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string, G literals and regular expression literals, ZWNJ, and ZWJ, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, ZWNJ and ZWJ may also be used in an identifier after the first character, BOM, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order, BOM. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files, BOM, characters are treated as white space characters, see 7.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 1. Code unit value, U200C, U200C, UFF.2 white space, name, 0 width non-joiner, 0 width joiner, byte, order mark, formal name, ZWNJ, ZWJ, BOM, usage, identifier part, white space, Table 1, format control character usage. White space characters are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space characters may occur between any two tokens and at the start or end of input. White space characters may also occur within a string literal or a regular expression literal, where they are considered significant characters forming part of the literal value, or within a comment, but cannot appear within any other kind of token. The ECMAScript white space characters are listed in Table 2. 4. Copyright sign, ECMA International 2009. Code unit value, U0009, U000B, U000C, U0020, U00A0, UFF. Other categories: EDS, name, tab, vertical tab, form feed, space, no break, space, byte, order mark, any other Unicode space separator, formal name, tab, VT, FF, SP, NBSP, BOM, USP. Table 2. White space characters. ECMAScript implementations must recognize all of the white space characters defined in Unicode 3.0. Later editions of the Unicode standard may define other white space characters. ECMAScript implementations may recognize white space characters from later editions of the Unicode standard. Syntax: white space, tab, VT, FF, SP, NBSP, BOM, USP. Point 3 line terminators. Like white space characters, line terminator characters are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space characters, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 7.9. A line terminator cannot occur within any token except a string literal. Line terminators may only occur within a string literal token as part of a line continuation. A line terminator can occur within a multi-line comment. 7.4. But cannot occur within a single line comment. Line terminators are included in the set of white space characters that are matched by the S-class in regular expressions. The ECMAScript line terminator characters are listed in Table 3. Table 3. Line terminator characters. Code unit value U000 U000D U2028 U2029. Name line feed carriage return line separator paragraph separator. Formal name LFCRLS. PS. Only the characters in Table 3 are treated as line terminators. Other new line or line breaking characters are treated as white space but not as line terminators. The character sequence CR, LF, is commonly used as a line terminator. It should be considered a single character for the purpose of reporting line numbers. ECMA International 2009-15. Syntax: line terminator, LF, CRLS, PS. Line terminator sequence, LF, CR look ahead, LF, LS, PS, CRLF. Point 4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any character except a line terminator character, and because of the general rule that a token is always as long as possible. A single line comment always consists of all characters from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important, because it implies that the presence or absence of single-line comments does not affect the process of automatic semicolon insertion. See 7.9. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator character, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax: comment, multi-line comment, single-line comment, multi-line comment, multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not asterisk, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, source character but not forward slash or asterisk, single line comment charsopt, single line comment chars, single line comment char, single line comment charsopt, 6. ECMA International 2009. Single line comment char. Source character but not line terminator. Point 5 tokens syntax. Token. Identifier name. Punctuator numeric literal string literal. Note the div punctuator and regular expression literal productions define tokens, but are not included in the token production. Point 6 identifier names and identifiers. Identifier n. Aims are tokens that are interpreted according to the grammar given in the identifiers section of Chapter 5 of the Unicode standard, with some small modifications. An identifier is an identifier name that is not a reserved word. C7, 6, 1. The Unicode identifier grammar is based on both normative and informative character categories specified by the Unicode standard. The characters in the specified categories in version 3.0 of the Unicode standard must be treated as in those categories by all conforming ECMAScript implementations. This standard specifies specific character additions. The $, and the underscore are permitted anywhere in an identifier name. Unicode escape sequences are also permitted in an identifier name, where they contribute a single character to the identifier name, as computed by the CV of the Unicode escape sequence, C7, 8, 4. The preceding the Unicode escape sequence does not contribute a character to the identifier name. A Unicode escape sequence cannot be used to put a character into an identifier name that would otherwise be illegal. In other words, if a Unicode escape sequence were replaced by its Unicode escape sequence's CV, the result must still be a valid identifier name that has the exact same sequence of characters as the original identifier name. All interpretations of identifiers within this specification are based upon their actual characters regardless of whether or not an escape sequence was used to contribute any particular characters. To identify a name that are canonically equivalent according to the Unicode standard and not equal unless they are represented by the exact same sequence of code units. In other words, conforming ECMAScript implementations are only required to do bitwise comparison on identifier name values. The intent is that the incoming source text has been converted to normalized form C before it reaches the compiler. ECMAScript implementations may recognize identifier characters defined in later editions of the Unicode standard. If portability is a concern, programmers should only employ identifier characters defined in Unicode 3.0. Syntax identifier. Identifier name but not reserved word. Identifier name. Identifier start. Identifier name. Identifier part. ECMA International 2009-17. Identifier start. Unicode letter. Unicode escape sequence. Identifier part. Identifier start. Unicode combining mark. Unicode digit. Unicode connector punctuation. ZWNJ, ZWJ, Unicode letter. Any character in the Unicode categories uppercase letter, LU, lowercase letter, LL, titlercase letter, LT, modifier letter, LM, other letter, low, or letter number, NL, Unicode combining mark. Any character in the Unicode categories non-spacing mark MN, or combining spacing mark MC. Unicode digit. Any character in the Unicode category decimal number. ND. Unicode connector punctuation. Any character in the Unicode category connector punctuation. PC. Unicode escape sequence. SER E7, 8, 4, 6.1 reserved words. A reserved word is an identifier name that cannot be used as an identifier. Syntax. Reserved word. Keyword. Future reserved word null literal boolean literal. 6, 1. 1 keywords. The following tokens are ECMAScript keywords and may not be used as identifiers in ECMAScript programs. Syntax. Keyword. 1 of break, case, catch, continue, debugger, default, delete, do, else, finally. 4. Function. If, in, instantia, type of new var return void switch while this with throw, try. 8. ECMA International 2009. 7, 6, 1. 2 future reserved words. The following words are used as keywords in proposed extensions and are therefore reserved to allow for the possibility of future adoption of those extensions. Syntax. Future reserved word. 1 of class enum extends superconst export import. The following tokens are also considered to be future reserved words when they occur within strict mode code. C10, 1, 1. The occurrence of any of these tokens within strict mode code in any context where the occurrence of a future reserved word would produce an error must also produce an equivalent error. Implements let private public interface package protected static. Point 7 Punctuators syntax. Punctuator 1 of yield, comma equals 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 plus percent and equals plus equals 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 and equals equals. Div punctuator 1 of equals. Point 8 literals syntax. Literal, null literal, boolean literal, numeric literal, string literal, regular expression literal, comma 8.1 null literals syntax. Null literal, null equals 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 plus colon percent equals equals equals. ECMA International 2009. 9 semantics. The value of the null literal null is the sole value of the null type.
So like this part of the stream, whenever I'm like picking apart the x86 ISA instruction set architecture, when I get to ARM assembly, I'll pick apart the ARM too. So I haven't designed a physical processor yet, so who am I to judge? But when I do, if I do, someday, I don't know. So, I don't know. It's all just opinion related. But I'm writing code. So that's like my point of view. So like, I'm gonna pick at this processor. I'm gonna pick at the Raspberry Pi 4 also, because that's what I'm gonna like run code on next. After I figure out x86, I gotta figure out ARM. I'm gonna like do a Raspberry Pi, and then I'll go for Apple later.
Hex integer literal 0x hex digit 0x hex digit exponent part opt.
Because chatbot said that they run the same ARM64 instruction set.
789 abdef abcdef. The source character immediately following a numeric literal must not be an identifier start or decimal digit. Note, for example, 3 inches is an error and not the two input elements 3 and in. Semantics. A numeric literal stands for a value of the number type. This value is determined in 2 steps. First, a mathematical value, MV, is derived from the literal. Second, this mathematical value is rounded as described below. The MV of numeric literal, decimal literal is the MV of decimal literal. The MV of numeric literal, hex integer literal is the MV of hex integer literal. The MV of decimal literal, decimal integer literal is the MV of decimal integer literal. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal plus the MV of decimal digits times 10n, where n is the number of characters in decimal digits. The MV of decimal
Something wrong with the Mac.
is the MV of decimal integer literal times 10e, where e is the MV of
It's like stuck.
decimal literal, decimal
It's stuck above the toolbar.
part is the MV of decimal integer literal plus.
How does this even happen? Oh, there it goes.
D is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits times 10n, where n is the number of characters in decimal digits. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits times 10en, where n is the number of characters in decimal digits and e is the MV of exponent part. The MV of decimal literal. Decimal integer literal is the MV of decimal integer literal. The MV of decimal literal. Decimal integer literal exponent part is the MV of decimal integer literal times 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal. Non-zero digit decimal digits is the MV of non-zero digit times 10n plus the MV of decimal digits, where n is the number of characters in decimal digits. The MV of decimal digit.
The Raspberry Pi 4 has a ARM processor. So after I gotta get x86, 64 figured out for now. This one get gonna get back to whatever. I did a 12-hour stream before this one, so I'm just gonna like pick up from there. So like I'm gonna get the PC figured out, 64-bit first,
The envy of decimal digit.
or at least get started on figure out how I'm gonna set it all up.
Digit. 1 or of non-zero digit. 1. The envy of decimal digit. 2 or of non-zero digit. 2. The envy of decimal digit. 3 or of non-zero digit. 3. The envy of decimal digit. 4 or of non-zero digit. 4. The envy of decimal digit. 5 or of non-zero digit. 5. The envy of decimal digit.
And after that, I figure out x86-64 for PC.
7.
I'm gonna go through I still have to convert stuff or whatever.
The envy of decimal digit. 9 or of non-zero digit. 9. The envy of hex digit. A or of hex digit. A is 10. The envy of hex digit. B or of hex digit. B is 11. ECMA International 2009. 1 or of H hex digit. 1 is 1 or of hex digit. 2 is 2 or of hex digit.
1 sec.
Of hex digit. 4 is 4 or of hex digit. 5 is 5 or
Wow, the headphones were really loud. I almost blew out my ears.
9 is 9, comma the envy of hex digit. C or of hex digit. C is 12, the envy of hex digit. D or of hex digit. D is 13, the envy of hex digit. E or of hex digit. E is 14, the envy of hex digit. F or of hex digit. F is 15, the envy of hex integer.
So right now, I have a prison style countdown. So like, I don't know, I'm getting funky with the tailies and the marks and ticks, whatever. Kind of like you do in prison. Because I have part of the engine done. And I don't know how long. I think like 8-9 days I have left to convert it. I have notes, whatever,
The number value for the MV, as specified in 8.5.
here, whatever. So I'm like kind of keeping track of all things I gotta do. So I gotta go through the C program I have, finish converting it, disassembly, I'm gonna have to get to it at some point because I have to figure out how.
Exponent pardon. It is not 0, or there is a nonce arrow digit to its left and there is a nonce arrow digit, not in the exponent part, to its right. A conforming
I'm gonna attach functions and stuff at runtime because my engine's in C. There's no virtualization, and 64-bit mode is different to 32-bit. So I don't know. That's what I'm trying to figure out now.
character.
So I wanted to like figure this out, do some speed tests to prove that like, well, not really prove. I need to figure out if I write assembly, how much faster will it be than the C compiler. That's why I'm doing it, not really to prove. I need to know how much faster and if it's worth it.
Terminator escape sequence, line continuation, single string character, source character but not single quote or backslash or line terminator escapes.
Because 64-bit is like a whole new beast when it comes to like programming.
2009. Escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Character escape sequence. Single escape.
I don't know. I explained it earlier in last stream. But there's the restriction between 32-bit and 64-bit mode.
Character. Single escape character.
there's like no overlap between the two. And I have to figure out if I write assembly, how much faster will it be in general. So like, I know I can write code that's faster than Visual Studio.
For a value of the string type. The string value, SV.
This is what Visual Studio output for some C code I gave it. And this is the same C code, but from like GNU compiler, I think Clang or whatever.
Mathematical value, MV, as described below or in 7.
I think my code was like instructions, 15. This is 12. So mine's like 3 instructions more than this, but it's a lot less than Visual Studio, which is at 26.
Characters. The SV of double string characters.
So if I write the bottlenecks of my engine in assembly language, it'll give me like a huge edge over the modern C compiler. So I need to like speed test this stuff. I still have to convert the rest of my program to 64-bit. So I wanted to simply speed test stuff and figure this out quickly, but it's taken a couple days. But I'm really close to like figuring it all out. And now I'm almost able to speed test stuff. There's like a real time, and then there's a cycle count. So I'm gonna like time the cycle count and the real time so I can get a real good comparison, because the cycle time is different than real time. The cycle time is the cycles on the CPU. So
CV of single string character.
if you have a CPU that has a whole bunch of ports that can access a whole bunch of instructions simultaneously, technically speaking, nothing is simultaneous. But it appears to be so it's close enough to call it that.
Unicode value 0000. The CV of escape C.
If it does out of order execution, it can technically do 2 things at the same time in the same cycle. So like if Visual Studio is 26 instructions and somehow the CPU can miraculously do 2 cycles, do 2 instructions per cycle in 1 cycle, then 26 would be 13, which is close to the same time as needed for the GNU output or Clang. But Clang, under the same conditions, if it could do 2 instructions per cycle for out of order execution, it'd be 12 down to 6. So in the end, Clang would still be faster. So that's like cycle count. Cycle count doesn't, the cycle counting, like the cycles of instructions, it doesn't account for real time or pipeline. It only accounts for how many cycles the instructions were. So I'm going to get that time to get like an idea of how many cycles. But then I'm also going to get real time. So I got to like average out the time of the real time counter, pick out the minimum, maximum, the outlier, and then account for the static, subtract that from the total,
Digit plus the MV of the 4th hex digit.
and then I'll run some speed tests. And then I'll have like a good base point of how much faster my assembly is. If it is faster, it might not be. I'm assuming it would be, because I was good at 32-bit assembly. But I have to learn 64-bit. I'm pretty sure I can get it. But if it is faster, I'll know or whatever after I finish up this stuff to test things. So then when I actually get to writing the engine and I get to the standards, which are somewhere,
Expression literals in a program evaluate to regular
and I actually get to like these standards, whatever, then I'll know if it's worth writing an assembly or not. So I don't know. That's where I'm at. So like I'm converting the engine I have, the parts that I have. I don't have all the mechanisms. I kind of explained that earlier. But when I do, I'm going through the standard. Now that I kind of got my feet wet, the 64-bit assembly, for x86 at least, I'll kind of have like a clue as to like,
An implementation may extend the regular expression constructor's grammar, but it must not extend the regular expression body and regular expression flags productions or the productions.
how much faster and where I need to like optimize the code and if it's even worth it or whatever. So I don't know. That's where I'm at right now. So if I can get this stuff done as soon as possible, I don't know, that's good. That means I have less days on my prison count.
But not or. Capital R E
So right now,
U L A R capital E X P R E S S I
it outputs this window, whatever.
B A C K S L A.
And I need to turn this into a macro. So I don't know. I'm gonna get to that. I guess I'll explain afterwards what it's doing, whatever. Because I like ran out of things to explain. So I know I'm trying to get to work. And I'll like summarize whatever in a bit. And like after I get 64-bit assembly,
Capital B
like totally figured out and understand it, then I'll make like a little tutorial, whatever, or something. So if you want to learn to code in assembly, you could like follow along or whatever. Because right now I'm just kind of like trying to get down on my stuff. But now and then I might make some code that's easier for you to like follow along, whatever. So I don't know. I'm gonna try to like get to work or whatever. So I think that's everything. So I'm gonna try to get to work. And I'll like summarize wherever I'm at after I make some progress. Because nothing's gonna get done if I'm talking as I'm doing it. So I don't know. I'm gonna turn on some loud music and try to get to work.
regular expression non-terminator but not, or capital R E G U L A R capital E X P R E S S I O N capital B A C K S L A S H capital S E Q U regular expression flags empty regular expression flags identify a part. Note regular expression literals may not be empty. Instead of representing an empty regular expression literal, the characters start a single line comment. To specify an empty regular expression, use dart semantics. A regular expression literal evaluates to a value of the object type that is an instance of the standard built-in constructor EXP. This value is determined in two steps. First, the characters comprising the regular expression's regular expression body and regular expression flags production expansions are collected uninterpreted into two strings pattern and flags, respectively. Then each time the literal is evaluated, a new object is created as if by the expression new regexp pattern flags, where regexp is the standard built-in constructor with that name. The newly constructed object becomes the value of the regular expression literal. If the call to new regexp would generate an error as specified in 151041, the error must be treated as an early error. Clause 16.9 Automatic semicolon insertion. Certain ECMAScript statements, empty statement, variable statement, expression statement, do while statement, continue statement, break statement, return statement, and throw statement must be terminated with semicolons. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. ECMA International 2009-25. 7. 9. 1 Rules of automatic semicolon insertion. There are 3 basic rules of semicolon insertion. When, as the program is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar, then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is when, as the program is passed from left to right, the end of the input stream of tokens is encountered and the parser is unable to parse the input token stream as a single complete ECMAScript program. Then a semicolon is automatically inserted at the end of the input stream. When, as the program is passed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production, and therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the 2 semicolons in the header of a for statement C1, 2, 6, 3. Note, the following are the only restricted productions in the grammar. Postfix expression, left-hand side expression, no line terminator here, plus left-hand side expression, no line terminator here. Continue statement, continue, no line terminator here, identify rot. Break statement, break, no line terminator here, identify rot. Return statement, return, no line terminator here, expression alt. Throw statement, throw, no line terminator here, expression. The practical effect of these restricted productions is as follows. When a or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the or token, then a semicolon is automatically inserted before the or token. When a continue, break, return, or throw token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, or throw token. The resulting practical advice to ECMAScript programmers is, a postfix or operator should appear on the same line as its operand. An expression in a return or throw statement should start on the same line as the return or throw token. The identifier in a break or continue statement should be on the same line as the break or continue token. 6. Copyright sign. ECMA International 2009. 7. 9. 2 examples of automatic semicolon insertion. The source, 12. 3, is not a valid sentence in the ECMAScript grammar, even with the automatic semicolon insertion rules. In contrast, the source, 1, 2, 3, is also not a valid ECMAScript sentence, but is transformed by automatic semicolon insertion into the following, 1, 2, 3, which is a valid ECMAScript sentence. The source, 4, A, B, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source is transformed by automatic semicolon insertion into the following. Return a plus b. Note the expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. The source is transformed by automatic semicolon insertion into the following. A equals b plus c. Note the token plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus. The source, if a b else c equals d, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point, because an automatically inserted semicolon would then be passed as an empty statement. The source, a equals b plus c, d plus c print, is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call. A equals b plus c, d plus c print, return a plus b, a equals b plus c. ECMA International 2009-27. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. Types. Algorithms within this specification manipulate values, each of which has an associated type. The possible value types are exactly those defined in this clause. Types are further subclassified into ECMAScript language types and specification types. An ECMAScript language type corresponds to values that are directly manipulated by an ECMAScript programmer using the ECMAScript language. The ECMAScript language types are undefined: null, boolean, string, number, and object. A specification type corresponds to meta values that are used within algorithms to describe the semantics of ECMAScript language constructs and ECMAScript language types. The specification types are reference, list, completion, property descriptor, property identifier, lexical environment, and environment record. Specification type values are specification artifacts that do not necessarily correspond to any specific entity within an ECMAScript implementation. Specification type values may be used to describe intermediate results of ECMAScript expression evaluation, but such values cannot be stored as properties of objects or values of ECMAScript language variables. Within this specification, the notation type X is used as shorthand for the type of X, where type refers to the ECMAScript language and specification types defined in this clause. Point 1. The undefined type. The undefined type has exactly one value, called undefined. Any variable that has not been assigned a value has the value undefined. 8.2. The null type. The null type has exactly one value, called null. 8.3. The Boolean type. The Boolean type represents a logical entity having two values, called true and false. 8.4. The string type. The string type is the set of all finite ordered sequences of 0 or more 16-bit unsigned integer var Louise elements. The string type is generally used to represent textual data in a running ECMAScript program, in which case each element in the string is treated as a code unit value. See clause 6. Each element is regarded as occupying a position within the sequence. These positions are indexed with non-negative integers. The first element, if any, is at position 0, the next element, if any, at position 1, and so on. The length of a string is the number of elements, that is, 16-bit values within it. The empty string has length 0 and therefore contains no elements. When a string contains actual textual data, each element is considered to be a single UTF-16 code unit. Whether or not this is the actual storage format of a string, the characters within a string are numbered by their initial code unit element position as though they were represented using UTF-16. All operations on strings, except as otherwise stated, treat them as sequences of undifferentiated 16-bit unsigned integers. They do not ensure the resulting string is in normalized form, nor do they ensure language-sensitive results. Note the rationale behind this design was to keep the implementation of strings as simple and high-performing as possible. The intent is that textual data coming into the execution environment from outside, for example, user input, text read from a file or received over the network, etc. Be converted to Unicode normalized form C before the running program. 8. Copyright sign. ECMA International 2009 sees it. Usually this would occur at the same time incoming text is converted from its original character encoding to Unicode, and would impose no additional overhead. Since it is recommended that ECMAScript source code be in normalized form C, string literals are guaranteed to be normalized, if source text is guaranteed to be normalized, as long as they do not contain any Unicode escape sequences. Point 5. The number type. There are two other special values, called positive infinity and negative infinity. For brevity, these values are also referred to for expository purposes by the symbols plus and, respectively. Note that these two infinite number values are produced by the program expressions plus infinity, or simply infinity and infinity. The other 1843776874454810624, that is, 263, values are kaye d the finite numbers. Half of these are positive numbers and half are negative numbers. For every finite positive number value there is a corresponding negative value having the same magnitude. Note that there is both a positive 0 and a negative 0. For brevity, these values are also referred to for expository purposes by the symbols plus 0 and 0, respectively. Note that these two different 0 number values are produced by the program expressions plus 0, or simply 0, and minus 0, SM2, E, where S is plus 1 or 1, M is a positive integer less than 253 but not less than 252, and E is an integer ranging from 1074 to 971, inclusive. The remaining 9007199254740990, that is, 253 values are denormalized, having the form SM2E, where S is plus 1 or 1, M is a positive integer less than 252, and E is 1074. Note that all the positive and negative integers whose magnitude is no greater than 253 are representable in the number type. Indeed, the integer 0 has two representations, plus 0 and minus 0. A finite number has an odd significant if it is non-zero and the integer M used to express it, in one of the two forms shown above, is odd. Otherwise, it has an even significant. In this specification, the phrase the number value for x where x represents an exact non-zero real mathematical quantity which might even be an irrational number such as b, means a number value chosen in the following manner. Consider the set of all finite values of the number type, with 0 removed and with two additional values added to it that are not representable in the number type, namely 21,024, which is plus 1 times 253 2971, and 21,024, which is 1 times 253 2971. Choose the member of this set that is closest in value to x if two values of the set are equally close. Then the one with an even significant is chosen. For this purpose, the two extra values 21,024 and 21,024 are considered to have even significance. Finally, if 21,024 is chosen, replace it with plus. If 21,024 is chosen, replace it with. If plus 0 was chosen, replace it with 0 if and only if x is less than 0. Any other chosen value is used unchanged. The result is the number value for x. This procedure corresponds exactly to the behavior of the IEE 754 round to nearest mode. ECMA International 2009-29. Some ECMAScript operators deal only with integers in the range 231 through 231 inclusive, or in the range of 0 through 232 inclusive. These operators accept any value of the number type but first convert each such value to one of 232 integer values. See the descriptions of the TOINT32 and TOINT32 operators in 9.5 and 9.6, respectively. Point 6. The object type. An object is a collection of properties. Each property is either a named data property, a named accessor property, or an internal property. A named data property associates a name with any ECMAScript language value and a set of Boolean attributes. A named accessor property associates a name with one or two accessor functions and a set of Boolean attributes. The accessor functions are used to store or retrieve an ECMAScript language value that is associated with the property. An internal property has no name and is not directly accessible via ECMAScript language operators. Internal properties exist purely for specification purposes. There are two kinds of access for named, non-internal properties, get and put, corresponding to retrieval and assignment, respectively. 6.1 Property attributes. Attributes are used in this specification to define and explain the state of named properties. A named data property associates a name with the attributes listed in Table 5. Value. Configurable. Any ECMAScript language type Boolean. Boolean. The value retrieved by reading the property. If false, attempts by ECMAScript code to change the property's attribute using. If false, attempts to delete the property, change the property to be an accessor property, or change its attributes, other than, will fail. Table 5. Attributes of a named data property. Attribute name. Value domain. Description. A named accessor property associates a name with the attributes listed in Table 6. 0. Copyright sign. ECMA International 2009. Boolean. If true, the property is to be enumerated by a for an enumeration. C1 2 6 4. Otherwise, the property is said to be non-enumerable. If false, attempts to delete the property, change the property to be a data property, or change its attributes will fail. Table 6. Attributes of a named accessor property. Attribute name. Value domain. Description. Object or undefined. If the value is an object, it must be a function object. The function's internal method, 862, is called with an empty arguments list to return the property value each time a get access of the property is performed. Object or undefined. If the value is an object, it must be a function object. The function's internal method, 862, is called with an arguments list containing the assigned value as its sole argument each time a set access of the property is performed. The effect of a property's internal method. If the value of an attribute is not explicitly specified by this specification for a named property, the default value defined in Table 7 is used. Table 7. Default attribute values. Attribute name. Default value. Undefined. Set. Writable. 6.2 Object internal properties and methods. Undefined. False. This specification uses various internal properties to define the semantics of object values. These internal properties are not part of the ECMAScript language. They are defined by the specification purely for expository purposes. An implementation of ECMAScript must behave as if it produced and operated upon internal properties in the manner described here. The names of internal properties are enclosed in double square brackets. When an algorithm uses an internal property of an object and the object does not implement the indicated internal property, a type error exception is thrown. The Table 8 summarizes the internal properties used by this specification that are applicable to all ECMAScript objects. The Table 9 summarizes the internal properties used by this specification that are only applicable to some ECMAScript objects. The descriptions in these tables indicates their behavior for native ECMAScript objects, unless stated otherwise in this document for particular kinds of native ECMAScript objects. Host objects may support these internal properties with any implementation-dependent behavior as long as it is consistent with the specific host object restrictions stated in this document. The value type domain columns of the following tables define the types of values associated with internal properties. The type names refer to the types defined in Clause 8 augmented by the following additional names. Any means the value may be any ECMAScript language type. Primitive means undefined, null, boolean, string, or number. Spec-op means the internal property is an internal method, an implementation-provided procedure defined by an abstract operation specification. Spec-op is followed by a list of descriptive ECMA International 2009 31 parameter names. If a parameter name is the same as a type name, then the name describes the type of the parameter. If a spec-op returns a value, its parameter list is followed by the symbol and the type of the returned value. Internal property, prototype, extensible, get property, put, can put, has property, delete, default value, value type domain, object or null string, boolean, spec-op, property name, any, spec-op, property name, undefined or property descriptor, spec-op, property name, undefined or property descriptor, spec-op, property name, any, boolean, spec-op, property name, boolean, spec-op, property name, boolean, spec-op, property name, boolean, boolean, spec op, hint, primitive spec op, property name, property descriptor, boolean, boolean, description, the prototype of this object, a string value indicating a specification-defined classification of objects. If true, own properties may be added to the object. Returns the value of the named property. Returns the property descriptor of the named own property of the
So like first, whatever.
descriptor of the named property of
I'm making macros or a macro to define these parameters with a tag name called log position of highest bit. It doesn't matter what its name, it's just a name. And then I'm gonna have that relate to this list of values. And I need this macro set up, make sure it's working, and I can template it. So this is one list that's gonna print the position of the bit set, the result. And I'll make another list that'll print the timing, the real time. I'll make another list that'll print the cycle timing. And I can tell how much faster or how much faster I can make the handwritten assembly compared to C compiler output.
host object as it depends on the implementation. Every chain must have finite length, that is, starting from any object, recursively accessing the internal property must eventually lead to a null value. Named data properties of the object are inherited, are visible as properties of the child object, for the purposes of get access, but not for put access. Named access are
I don't know if I covered this earlier.
Boolean valued internal property that controls whether or not named properties may be added to the object.
But the instruction set, architecture, whatever, like you know how you pay for your high-end CPU and you expect performance.
Modified. Once the value of an internal property has been set to false, it may not be subsequently changed to true. Note this specification defines no ECMAScript language operators or
I don't know, maybe you don't expect performance. But if you buy a gaming CPU, I don't know why you wouldn't expect performance.
specific extensions that modify.
I'm like writing my engine for gaming. If it's fast enough, I don't know till like I start testing things, but that's the goal, whatever.
Property of a host object may be any string value except one of arguments.
So I'm gonna like test out the MMX instructions, SSE, SSE2, SSE3, SSSE3. Where's AVX? The AVX, AVX2, FMA.
That value except through object prototype to string.
So all the like specialty instructions that are added, the instruction set.
X behaviors describe.
After I'm like set up with the basic things in assembly.
5, 4, 5, 1, and string objects have a slightly different.
Like this stuff, whatever, like 64-bit general purpose registers. Then I'll like dig into like optimizing
Host objects may implement these internal methods in any manner unless specified otherwise.
and testing if like AVX2 is even worth it. Because it says it's a 256-bit. So like if it actually is faster than 64-bit, and I could like unroll loops, pack data to get the advantage. If I test it though, then I'll write my engine, whatever, to support this. If your CPU has it, the current JavaScript engine, they can't do that. They don't know how to, they can't even hint at how to optimize for this stuff without giving away huge clues. But there's ways to optimize things in JavaScript, even though it's dynamically typed. you can't optimize it, JavaScript, for anything. You have to break it down to its simplest form, which people that program a high-level language are unable to do. But I have like a good understanding of assembly and high-level language, so I'm gonna like throw it all together and sell an engine I wrote 7 years ago. I actually thought JavaScript would die because Tumblr died. I made like an overly complicated Tumblr theme maker. It was 3D and stuff. And I covered it a couple streams ago.
Spec ob, a list of any object.
And I wrote some code for the browser that the browser couldn't handle. So I had to like make parts of my own engine to like crunch numbers to output code for my Tumblr theme generator. And Tumblr went out of business. And I was like, well, JavaScript's gonna die too. Because they had CSS3, they had Flexbox, they had a whole bunch of new shit like 7 years ago. So I kind of gave up on it, did other things. And then I realized that JavaScript is bigger than ever. JavaScript is everywhere. And now is a perfect opportunity to release the fastest JavaScript engine. Because no one else is ever going to do it. It's not getting any faster. So I don't know. I'm going to be the first to it. Unless someone beats me to it. I don't know, good luck. Anyways. Whenever I'm done with like disassembly and like the general purpose stuff, then I'll test this stuff. I think I'll test the SSE instructions first. I don't know. It depends. This is a 15-year-old i7 that I have.
Created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property. List of any. The pre-bound argument values of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects.
It's i7 860 2.8 80 gigahertz. It only has 8 megabytes cache.
A match result value C1510221 of the standard built-in ECMAScript objects. Only regexp objects implement. Object provides a mapping between the properties of an arguments object C10.6 and the formal parameters of the associated function. Only ECMAScript objects that are arguments objects have a map.
Does it say cache? Oh, here.
Specification type.
It only has 8 megabytes of cache. So I'm programming on this CPU.
And the assignment operators. For example, the left-hand operand of an assignment is expected to produce a
because it's a first Gen i7.
2009 reference. The behavior of assignment.
So I go like this source table, set, stuff, whatever.
Form of the left-hand operand of an assignment operator, but for one difficulty, function calls are permitted.
The first i7 whatever, the 920. So like apparently that's a triple channel memory CPU. This CPU is the model after it. It only has double channel memory. But the instruction set, the timing.
Many parts of the specification. A reference is a resolved name binding. A reference consists of 3 components.
Is the same other than the memory access times and the bandwidth and stuff.
Base value is either undefined, an object, a boot.
So I'm going to try to optimize for like the CPU. Because this 15-year-old computer is like one potato.
Could not be resolved to a binding. The reference name is a string. The following abstract operations are used in this specification.
And every time AMD releases
V returns the base value component of the reference V, get reference name V,
AMD or Intel, whatever.
a strict reference v returns the strict reference component of the reference v has primitive base. V returns true if the base value is a boolean, string, or number.
Ivy bridge is like, or Sandy bridge, that's like 2 potatoes. This is 1 potato, 2 potato, 4th gen, 4 potatoes.
V returns true if the base
6, 7, 8, 9, 10, 11 potatoes, whatever.
abstract
They're all potatoes based off this potato. So I'm optimizing for this potato, the least common potato, and I can update it and optimize it for the more modern potatoes. Because the 8 megabyte cache,
be the internal method defined
the CPU, it gives me a benefit because I can tell what code is good or bad right away because I'm limited, but I have 32 gigs of RAM.
C1021 concrete method of base parsing. Get reference name v and is strict reference v as arguments. The following wing steps are taken. Let O be to object base. Let desk be the result of calling the internal method of O with property name p. If desk is undefined, return undefined.
So, I don't know. 15-year-old CPU, 8 megabytes cache. The good code is going to run better. It's more obvious because I have a smaller cache, so I can tell what's good code or bad code. Because when it's not very good code, it's going to have to page more. And it won't have to page until it hits more than 32 gigs of RAM, which is pretty good. So I have like, this is a literal potato, but it has like just enough resources. So it's like, I don't know. It should be good to optimize with. And I can optimize for later CPUs, newer ones. If I optimize for the newest CPU, the performance on other CPUs, it's like totally unknown. If I optimize for this, I'm going to meet all the CPUs because they're all based off this architecture, whatever, at least currently with Intel. I don't think they're going to be changing the architecture anytime soon.
For the throw flag, else base must be
Because they're like neck to neck with AMD. I don't think they'd risk that much money. They're like barely making it.
reference name v w
Whatever.
as arguments. Return the following. Let O be
I should stop picking at companies.
false. Then, if throw is true, then
Or not, because it is kind of factual. Based on context. That's what chatbot always says. So I don't know. That's why I'm writing an assembly, whatever. So at some point, whenever I stop talking and I get back to work and I update it so I can template this list to print other lists, I'll be closer to speed testing and closer to like writing assembly for like the extended instruction set and stuff. Like, I don't know, whatever.
outside of the above method. An implementation
So like, right now, I'm making macro.
situations where such an actual property assignment that uses this internal method can have visible effect to when it either in
Everything works right now, so I don't want to break it. But I gotta like tag everything I have with this new keyword. So I can call this macro
type. The list type is used to explain the evaluation of argument lists.
which is right here, and it passes an argument, which is a tag word. So what I'll do is tag it like this. I'll define this as its own instance. And then I don't have to like define everything individually. I can just define it like this, give it a tag name, and that's it. So first, I have to define everything that's in use, like these. I have to make the new defines with the new tag name.
ECMAScript identifier or empty. The term abrupt completion refers to any completion with a type other than normal.
So like it'll glue it like that. I'm gonna define them to the current name like that. So that way, if it's working and it's gluing the tokens, like if this works, then it means that it's successfully glued the tokens and defined them to the current defines. And if that works, then I'm safe to like delete this macro and make a new macro that redefines these to types. So I'm like, I have things set up for one instance here, whatever, and it works perfectly fine. I don't want to define it over and over. So I'm like working my way backwards to define things to the other things until I get to like this level, and I'll be able to define the innermost level, and then I'll be able to like take this and then call it like a speed test or benchmark. So after I define things and it's working for this type and everything's tagged with this, then I can simply redefine things with the same macros. And this is a list, whatever. For the position of the bit, the result, whatever. That's what this list is right now. So then add another list under it called wall time. So this whole thing will be templated. I can change the type, and I'll print wall time under it. And then the same thing, whatever, for the CPU cycles. And I'll like print that to its own list under the other list, and then I can get the real time it took to complete, and also the CPU cycles. And then from that I can like determine the benefit, whatever, if there is any. I assume there's a lot of writing assembly and weigh like the cost or whatever. And I'll be able to like run Visual Studio output versus Clang, I think, or I don't know, it's Clang versus Clang, whatever. I don't know. So I have to get these lists like templated and running. Now I'll do this stuff. This is really boring stuff. At some point, after like figure out more stuff, I kind of like have a better hang of it. I'll make a tutorial or something. But until then, I don't know. I'm still trying to like figure it out because 64-bit is different than 32-bit. There's less control. There's less like functionality. It used to be like segmented memory, and now like there's a magical 2 GB segment. I don't know. It's magical. It's not the same as 32-bit, and lots of like privileges were removed, so it kind of makes it more difficult to write a program, but possibly easier because there's less variety and stuff. So maybe it's better. So I don't know. I still have to like figure it out, wrap my head around it, and then I can like explain it better and make a tutorial or something. I don't know. That's where I'm at. So I'm like, take a break or whatever, get some water. To get it to after I template this, whatever, the mic's cutting out. After I template this, I'll template for these, and I'll be able to like print the address because I want to check the address space too, and I also want to print the time. I don't know. After this stuff, I'll actually be like, feel like I'm making progress because I've been going back and forth, whatever, trying to just figure out 64-bit. So I don't know. I'll BRB and working on setting up these lists and stuff.
If a parameter name is the same as a type name, then the name describes the type of the parameter. If a spec op returns a value, its parameter list is followed by the symbol and the type of the returned value. Internal property, prototype, extensible, get property, put, can put, has property, delete, default value, value type domain, object or null string, boolean, spec op, property name, any, spec op, property name, undefined or property descriptor, spec op, property name, undefined or property descriptor, spec op, property name, any, boolean, spec op, property name, boolean, spec op, property name, boolean, spec op, property name, boolean, boolean, spec op, hint, primitive spec op, property name, property descriptor, boolean, boolean, description, the prototype of this object, a string value indicating a specification-defined classification of objects. If true, own properties may be added to the object. Returns the value of the named property. Returns the property descriptor of the named own property of this object, or undefined if absent. Returns the fully populated property descriptor of the named property of this object, or undefined if absent. Sets the specified named property to the value of the second parameter. The flag controls failure handling. Returns a Boolean value indicating whether returns a Boolean value indicating whether the object already has a property with the given name. Removes the specified named own property from the object. The flag controls failure handling. Hint is a string. Returns a default value for the object. Creates or alters the named own property to have the state described by a property descriptor. The flag controls failure handling. Table 8. Internal properties common to all objects. Every object, including host objects, must implement all of the internal properties listed in Table 8. However, the internal method may, for some objects, simply throw a type error exception. All objects have an internal property called. The value of this property is either null or an object and is used for implementing inheritance. Whether or not a native object can have a host object as it depends on the implementation. Every chain must have finite length, that is, starting from any object, recursively accessing the internal property must eventually lead to a null value. Named data properties of the object are inherited, are visible as properties of the child object, for the purposes of get access, but not for put access. Named accessor properties are inherited for both getAccess and putAccess. Every ECMAScript object has a Boolean valued internal property that controls whether or not named properties may be added to the object. If the value of the internal property is false, then additional named properties may not be added to the object. In addition, if is false, the value of the internal properties of the object may not be modified. Once the value of an internal property has been set to false, it may not be subsequently changed to true. Note this specification defines no ECMAScript language operators or built-in functions that permit a program to modify an object's or internal properties or to change the value of from false to true. 2. Copyright sign. ECMA International 2009. Implementation-specific extensions that modify or must not violate the invariance defined in the preceding paragraph. The value of the internal property is defined by the specification for every kind of built-in object. The value of the internal property of a host object may be any string value except one of arguments: array, boolean, date, error, function, JSON, math, number, object, regexp, and string. The value of an internal property is used internally to distinguish different kinds of objects. Note that this specification does not provide any means for a program to access that value except through object prototype to string C15.2.4.2, unless otherwise specified. The common internal methods of native ECMAScript objects behave as described in 8.12. Array objects have a slightly different implementation of the internal method C15.4.5.1, and string objects have a slightly different implementation of the internal method C15.5.5.2. Arguments objects 10.6 have different implementations of, and function objects 15.3 have a different implementation of. Host objects may implement these internal methods in any manner unless specified otherwise. For example, one possibility is that for a particular host object indeed fetch and store property values but always generates false. However, if any specified manipulation of a host object's internal properties is not supported by an implementation, that manipulation must throw a type error exception when attempted. The internal method of a host object must conform to the following invariants for each property of the host object. If a property is described as a data property and it may return different values over time, then either or both of the and. If a property is described as a data property and it's and are both false, then the same value, according to 9.12, must be returned for the attribute of the property y on all calls to. If the attributes other than may change over time or if the property might disappear, then the attribute must be true. If the attribute may change from false to true, then the attribute must be true. If the value of the host object's internal property has been observed by ECMAScript code to be false, then if a call to describes a property as non-existent, all subsequent calls must also describe that property as non-existent. The internal method of a host object must not permit the addition of a new property to a host object if the internal property of that host object has been observed by ECMAScript code to be false. If the internal property of that host object has been observed by ECMAScript code to be false, then it must not subsequently become true. ECMA International 2009-33. Internal property value type description domain. Primitive internal state information associated with this object. Of the standard built-in ECMAScript objects, only Boolean, date, number, and string objects implement. Table 9. Internal properties only defined for some objects. Spec op. A list of any object creates an object. Invoked via the new operator. The arguments to the spec op. The arguments passed to the new operator. Objects that implement this internal method are called constructors. Spec op. Any. A list of any or reference executes code associated with the object. Invoked via a function call expression. The arguments to the spec op are this object and a list containing the arguments passed to the function call expression. Objects that implement this internal method are callable. Only callable objects that are host objects may return reference values. Spec op. Any. Boolean returns a Boolean value indicating whether the argument is likely an object that was constructed by this object. Of the standard built-in ECMAScript objects, Only function objects implement. Lexical environment. A lexical environment that defines the environment in which a function object is executed. Of the standard built-in ECMAScript objects, only function objects implement. List of strings. A possibly empty list containing the identifier strings of a function's formal parameter list. Of the standard built-in ECMAScript objects, only function objects implement. ECMAScript code. The ECMAScript code of a function. Of the standard built-in ECMAScript objects, only function objects implement. Object. The target function of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property any. The pre-bound this value of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property list of any. The pre-bound argument values of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property spec ob. String. Int x. Match result. Tests for a regular expression match and returns a match result value. C151021. Of the standard built-in ECMAScript objects, only regexp objects implement. Object provides a mapping between the properties of an arguments object, C10.6, and the formal parameters of the associated function. Only ECMAScript objects that are arguments objects have an internal property. 8.7 The reference specification type. The reference type is used to explain the behavior of such operators as delete, type off, and the assignment operators. For example, the left-hand operand of an assignment is expected to produce a 4 copyright sign, ECMA International 2009 reference. The behavior of assignment could, instead, be explained entirely in terms of a case analysis on the syntactic form of the left-hand operand of an assignment operator, but for one difficulty, function calls are permitted to return references. This possibility is admitted purely for the sake of host objects. No built-in ECMAScript function defined by this specification returns a reference, and there is no provision for a user-defined function to return a reference. Another reason not to use a syntactic case analysis is that it would be lengthy and awkward, affecting many parts of the specification. A reference is a resolved name binding. A reference consists of three components: the base value, the reference name, and the Boolean valued strict reference flag. The base value is either undefined, an object, a Boolean, a string, a number, or an environment record, 1 0, 2, 1. A base value of undefined indicates that the reference could not be resolved to a binding. The reference name is a string. The following abstract operations are used in this specification to access the components of references. GetBase v returns the base value component of the reference v. GetReferenceName v returns the reference name component of the reference v. IsStrictReference v returns the strict reference component of the reference v. Has primitive base v returns true if the base value is a Boolean, string, or number. IsProperty reference v returns true if either the base value is an object or has primitive base v is true, otherwise returns false. IsUnresolvable reference v returns true if the base value is undefined and false otherwise. The following abstract operations are used in this specification to operate on references. 7.1 Get value v. If type v is not reference, return v. Let base be the result if calling getBase v. If is unresolvable reference v. Throw a reference error exception. If is property reference v. Then, if his primitive base v is false, then let get be the internal method defined below. B return the result of calling the get internal method using base as its this value, and passing get reference name v for the argument. Else, base must be an environment record. A return the result of calling the get binding value C10, 2, 1. Concrete method of base passing get reference name v and is strict reference v as arguments. The following let O be to object, base. Let desk be the result of calling the internal method of O with property name P. If desk is undefined, return undefined. If is data descriptor, desk, is true, return desk. Otherwise, is accessor descriptor, desk, must be true, so let getter be desk. If getter is undefined, return undefined. Return the result calling the internal method of getter providing bases to this value and providing no arguments. Note the object that may be created in step 1 is not accessible outside of the above method. An implementation might choose to avoid the actual creation of the object. The only situation where such an actual property access that uses this internal method can have visible effect is when it invokes an accessor function. 7.2 put value v w. If type v is not reference, throw a reference error exception. ECMA International 2009-35. 2. Let base be the result of calling getBase v. If is unresolvable reference v, then if is strict reference v is true, then I throw reference error exception. Be call the. Else if is property reference v, then if his primitive base v is false, then let put be the special. Be call the put internal method using base as its this value and passing get reference name v for the property name, w for the value, and is strict reference v for the throw flag. Else base must be a reference whose base is an environment record. So, I call the set mutable binding 1 0 2 1. Concrete method of base, passing get reference name v w and is strict reference v as arguments. Return the following. D by put value when v is a property reference with a primitive base value. It is called using base as its this value and with property p, value w, and boolean flag throw as arguments. The following steps are taken. Let O be to object base if the result of calling the internal method of O with argument p is false. Then, if throw is true, then throw a type error exception. B else return. Let own desk be the result of calling the internal method of O with argument p. If is data descriptor, own desk, is true, then if throw is true, then throw a type error exception. B else return. Let desk be the result of calling the internal method of O with argument p. This may be either an own or inherited accessor property descriptor or an inherited data property descriptor. If is accessor descriptor, desk, is true, then a let setter be desk. We call the internal method of setter providing bases to this value in an argument list containing only w. Else, this is a request to create a known property on the transient object O. If throw is true, then throw a type error exception 8. Return. Note the object that may be created in step 1 is not accessible outside of the above method. An implementation might choose to avoid the actual creation of that transient object. The only situations where such an actual property assignment that uses this internal method can have visible effect are when it either invokes an accessor function or is in violation of a throw predicated error check. When throw is true, any property assignment that would create a new property on the transient object throws an error. Point 8. The list specification type. The list type is used to explain the evaluation of argument lists. See 1 1, 2, 4, in new expressions, in function calls, and in other algorithms where a simple list of values is needed. Values of the list type are simply ordered sequences of values. These sequences may be of any length. Point 9. The completion specification type. The completion type is used to explain the behavior of statements break, continue, return and throw that perform non-local transfers of control. Values of the completion type are triples of the form type, value, target, where type is one of normal, break, continue, return, or throw. Value is any ECMAScript language value or empty, and target is any ECMAScript identifier or empty. The term abrupt completion refers to any completion with a type other than normal. 6. Copyright sign. ECMA International 2009. 8.10. The property descriptor and property identifier specification types. The property descriptor type is used to explain the manipulation and reification of named property attributes. Values of the property descriptor type are records composed of named fields where each field's name is an attribute name and its value is a corresponding attribute value as specified in 8, 6, 1. In addition, any field ma, y be present or absent. property descriptor values may be further classified as data property descriptors and accessor property descriptors based upon the existence or use of certain fields. A data property descriptor is one that includes any fields named either raw. An accessor property descriptor is one that includes any fields named either. Any property descriptor may have fields named, and a property descriptor value may not be both a data property descriptor and an accessor property descriptor. However, it may be neither. A generic property descriptor is a property descriptor value that is neither a data property descriptor nor an accessor property descriptor. A fully populated property descriptor is one that is either an accessor property descriptor or a data property descriptor and that has all of the fields that correspond to the property attributes defined in either 8, 6, 1 Table 5 or Table 6. For notational convenience within this specification, an object literal-like syntax can be used to define a property descriptor value. For example, property descriptor 42, false, true, defines a data property descriptor. Field name order is not significant. Any fields that are not explicitly listed are considered to be absent. In specification text and algorithms, dot notation may be used to refer to a specific field of a property descriptor. For example, if D is a property descriptor, then D is shorthand for the field of denamed. The property identifier type is used to associate a property name with a property descriptor. Values of the property identifier type are pairs of the form name, descriptor, where name is a string and descriptor is a property descriptor value. The following abstract operations are used in this specification to operate upon property descriptor values. 10.1 is accessor descriptor. Desk. When the abstract operation is accessor descriptor is called with property descriptor desk. The following steps are taken if desk is undefined. Then return false. If both desk are absent, then return false. Return true. 10.2 is data descriptor. Desk. When the abstract operation is data descriptor is called with property descriptor desk. The following steps are taken if desk is undefined. Then return false. If both desk and desk are absent, then return false. Return true. 10.3 is generic descriptor. Desk. When the abstract operation is generic descriptor is called with property descriptor desk. The following steps are taken if desk is undefined. Then return false. If is accessor descriptor, desk, and is data descriptor, desk, are both false. Then return true. Return false. ECMA International 2009 37 8 10 4 from property descriptor. Desk. When the abstract operation from property descriptor is called with property descriptor desk. The following steps are taken. The following algorithm assumes that desk is a fully populated property descriptor, such as that returned from C8 12 1. If desk is undefined, then return undefined. Let obj be the result of creating a new object as if by the expression new object, where object is the standard built-in constructor with that name. If is data descriptor, desk, is true, then call the internal method of obj with arguments value, property descriptor, desk, true, 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 and false. B call the internal method of obj with arguments writable, property descriptor, desk, true, 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 and false. Else is accessor descriptor, desk, must be true. So, call the internal method of obj with arguments get, property descriptor, desk, true, 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 and false. B call the internal method of obj with arguments set, property descriptor, desk, true, 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 and false. Call the internal method of obj with arguments enumerable, property descriptor, desk, true, 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 and false. Call the internal method of obj with arguments configurable, property descriptor, desk, true, 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 and false. Return obj, 10.5 to property descriptor. Obj, when the abstract operation to property descriptor is called with object desk. The following steps are taken if type obj is not object, throw a type error exception. Let desk be the result of creating a new property descriptor that initially has no fields. If the result of calling the internal method of obj with argument enumerable is true, then let enum be the result of calling the b set the field of desk to boolean enum. If the result of calling the internal method of obj with argument configurable is true, Then a let conf be the result of calling the b set the field of desk to boolean conf if the result of calling the internal method of obj with argument value is true. Then a let value be the result of calling the b set the field of desk to value if the result of calling the internal method of obj with argument writable is true. Then a let writable be the result of calling the b set the field of desk to boolean writable if the result of calling the internal method of obj with argument get is true. Then a let getter be the result of calling the b if is callable getter is false and getter is not undefined. Then throw a type error exception. C set the if the result of calling the internal method of obj with argument set is true. Then a let setter be the result of calling the b if is callable setter is false and setter is not undefined. Then throw a type error exception. C set the if either desk are present. Then if either desk or desk are present. Then throw a type error exception. 0. Return desk. 8. ECMA International 2009. 8.11 The lexical environment and environment record specification types. The lexical environment and environment record types are used to explain the behavior of name resolution in nested functions and blocks. These types and the operations upon them are defined in Clause 10.12 Algorithms for Object Internal Methods. In the following algorithm descriptions, assume O is a native ECMAScript object, P is a string, desk is a property description record, and throw is a boolean flag, 12.1 P. When the internal method of O is called with property name P, the following steps are taken. If O doesn't have a known property with name P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property named P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else X is an accessor property. So, A set D attribute, B set D attribute, set D to the value of X's attribute, set D to the value of X's attribute, return D. However, if O is a string object, it has a more elaborate internal method defined in 1.5.5.5.2, 12.2. P. When the internal method of O is called with property name P, the following steps are taken. Let prop be the result of calling the internal method of O with property name P. If prop is not undefined, return prop. Let proto be the value of the internal property of O. If proto is null, return undefined. Return the result of calling the internal method of proto with argument P, 12.3. When the D of O is called with property name P, the following steps are taken. Let desk be the result of calling the internal method of O with property name P. If desk is undefined, return undefined. 0. If is data descriptor, desk, is true, return desk. 1. Otherwise, is accessor descriptor, desk, must be true, so let getter be desk. 2. If getter is undefined, return undefined. 3. Return the result calling the internal method of getter providing O as the this value and providing no arguments, 12.4. P. When the internal method of O is called with property name P, the following steps are taken. Let desk be the result of calling the internal method of O with argument P. If desk is not undefined, then if is accessor descriptor, desk, is true, then
I might need to like make a new strategy.
return the value of desk. Let proto be the internal property of O. If proto is null, then return the value of the internal property of O. Let inherited be the result of calling the internal method of proto with property name P. If inherited is undefined, return the value of the internal property of O. If is accessor descriptor, inherited, is true, then if inherited be else return true. Else, inherited must be a data descriptor. If the internal property of O is false, return false. Be else return the value of inherited. Host objects may define additional constraints upon operations and situations where this definition of returns false, 12.5. When if the result of calling the internal method of O with argument P is false, then if throw is true, then throw a type error exception. Be else return. Let own desk be the result.
These things aren't defined before use, even though I define them before use.
P value desk.
So I gotta figure out
Internal method of O with argument P this
how to define things
So property.
before they're defined for use. So we gotta define things before they're used.
Let setter be desk
Even though in the code it's defined before it's used.
is the sole argument L
This is annoying.
on object O is
Someone try to figure that out. This sucks. Nice chatbot. It's probably not gonna help, but it might help. I was kind of like hoping
when the internal.
the defines would like just work,
The following steps are taken. Let desk be the result.
but it like apparently there's a catch, so I gotta like figure out a workaround. Fun stuff. So much fun.
Is called with property name P and the Boolean flag throw. The following steps are taken. Let desk be the result of calling the internal method of O with property name P. If desk is undefined, then return true. If desk is true, then 0. ECMA International 2009. A remove the own property with name P from O. P return true. Else if throw, then throw a type error exception. Return false, 12.8. Hint, when the internal method of O is called with hint string, the following steps are taken. Let toString be the result of calling the if is callable. toString is true then. Let str be the result of calling the internal method of toString, with O as the this value in an empty argument list. B if str is a primitive value. Return str. Let value of be the result of calling the if is callable. Value of is true then. Let val be the result of calling the internal method of value of with O as the this value in an empty argument list. B if val is a primitive value. Return val. Throw a type error exception. When the internal method of O is called with hint number, the following steps are taken. Let value of be the result of calling the if is callable. Value of is true then. Let val be the result of calling the internal method of value of with O as the this value in an empty argument list. B if val is a primitive value. Return val. Let toString be the result of calling the if is callable. toString is true then. Let str be the result of calling the internal method of toString, with O as the this value in an empty argument list. B if str is a primitive value. Return str. Throw a type error exception. When the internal method of O is called with no hint, then it behaves as if the hint were number, unless O is a date object. C1596. In which case it behaves as if the hint was string. The above specification for native O objects can return only primitive values. If a host object implements its own internal method, it must ensure that its internal method can return only primitive values. 12.9 p desk throw. In the following algorithm, the term reject means if throw is true, then throw a type error exception, otherwise return false. The algorithm contains steps that test various fields of the property descriptor desk for specific values. The fields that are tested in this manner need not actually exist in desk. If a field is absent, then its value is considered to be false. When the internal method of O is called with property name P, property descriptor desk, and Boolean flag throw, the following steps are taken. Let current be the result of calling the internal method of O with property name P. Let extensible be the value of the internal property of O. If current is undefined and extensible is false, then reject. If current is undefined and extensible is true, then if is generic descriptor, desk, or as data descriptor, desk, is true, then I create a known data property named P of object O whose enumerable and attribute values are described by desk. If the value of an attribute field of desk is absent, the attribute of the newly created property is set to its default value. ECMA International 2009 41. B else. Desk must be an accessor property descriptor, so I create an own accessor property named P of object O whose enumerable and attribute values are described by desk. If the value of an attribute field of desk is absent, the attribute of the newly created property is set to its default value. See return true. Return true if every field in desk is absent. Return true if every field in desk also occurs in current and the value of every field in desk is the same. Value is the corresponding field in current when compared using the same value algorithm. 9.12. If the field of current is false, then A reject. If the field of desk is true, B reject. If the field of desk is present and the fields of current and desk are the Boolean negation of each other, if is generic descriptor, desk, is true, then no further validation is required. Else, if is data descriptor current and is data descriptor desk have different results, then A reject. If the field of current is false, B if is data descriptor current is true, then I convert the property named P of object O from a data property to an accessor property. Preserve the existing values of the converted properties and attributes and set the rest of the properties' attributes to their default values. See else, I convert the property named P of object O from an accessor property to a data property. Preserve the existing values of the converted properties and enumerable attributes and set the rest of the properties' attributes to their default values. 10. Else, if is data descriptor current and is data descriptor desk are both true, then if the field of current is false, then I reject. If the field of current is false and the field of desk is true. 2. If the field of current is false, then reject. If the field of desk is present and same value, desk current is false. B else, the field of current is true, so any change is acceptable. 1. Else, is accessor descriptor current and is accessor descriptor desk are both true, so if the field of current is false, then I reject. If the current 2 reject. If the current 2 for each attribute field of desk that is present, set the correspondingly named attribute of the property named P of object O to the value of the field. 3. Return true. However, if O is an array object, it has a more elaborate internal method defined in 5, 4, 5, 1. Note step 10b allows any field of desk to be different from the corresponding field of current if current's field is true. This even permits changing the of a property whose attribute is false. This is allowed because a true attribute would permit an equivalent sequence of calls where is first set to true, and new is set, and then is set to false. Type conversion and testing. The ECMAScript runtime system performs automatic type conversion as needed. To clarify the semantics of certain constructs, it is useful to define a set of conversion abstract operations. These abstract operations are not a part of the language. They are defined here to aid the specification of the semantics of the language. The conversion abstract operations are polymorphic, that is, they can accept a value of any ECMAScript language type, but not of specification types. 2. Copyright sign. ECMA International 2009 9.1 to primitive. The abstract operation to primitive takes an input argument and an optional argument preferred type. The abstract operation to primitive converts its input argument to a non-object type. If an object is capable of converting to more than one primitive type, it may use the optional hint preferred type to favor that type. Conversion occurs according to Table 10. Input type, undefined null Boolean number string, point 2 to Boolean, Table 10. To primitive conversions. Result. The result equals the input argument no conversion. 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 Object. Return a default value for the object. The default value of an object is retrieved by calling the internal method of the object, passing the optional hint preferred type. The behavior of the internal method is defined by the specification for all native ECMAScript objects in 8.1.2. 8. The abstract operation to Boolean converts its argument to a value of type Boolean according to Table 11. Argument type, undefined null Boolean number, string object, point 3 to number, Table 11. To Boolean conversions. The result equals the input argument no conversion. The result is false if the argument is +0, 0, or none. Otherwise the result is true. The result is false if the argument is the empty string. Its length is 0. Otherwise the result is true. True. Result. False. False. The abstract operation to number converts its argument to a value of type number according to Table 12. ECMA International 2009 43. Argument type, undefined null Boolean, number string object. Table 12. To number conversions. Result, none +0. The result is 1 if the argument is true. The result is +0 if the argument is false. The result equals the input argument no conversion. See grammar and note below. Apply the following steps. Let prim value be to primitive. Input argument. hint number, return to number, prim value, 9, 3, 1. To number applied to the string type. To number applied to strings applies the following grammar to the input string. If the grammar cannot interpret the string as an expansion of string numeric literal, then the result of to number is nan, string numeric literal, str white spaciat, str white spaciat, str numeric literal, str white spaciat, str white space, str white space char, str white spaciat, str white space char, white space, line terminator, str numeric literal, str decimal literal hex integer literal, str decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, infinity decimal digits, decimal digits opt exponent part opt, decimal digits exponent part opt, decimal digits exponent part opt, decimal digits, decimal digit, decimal digits, decimal digit, decimal digit, 1 of 123,456,789, exponent part, exponent indicator signed integer, exponent indicator, 1 of EE, 4, ECMA International 2009, signed integer, decimal digits, decimal digits, decimal digits, hex integer literal, 0x hex digit, 0x hex digit, hex integer literal hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 abdef a b c d e f. Some differences should be noted between the syntax of a string numeric literal and a numeric literal. C7, 8, 3. A string numeric literal may be preceded and or followed by white space and or line terminators. A string numeric literal that is decimal may have any number of leading 0 digits. A string numery, C literal that is decimal may be preceded by plus or to indicate its sign. A string numeric literal that is empty or contains only white spaces converted to plus 0. The conversion of a string to a number value is similar overall to the determination of the number value for a numeric literal. C7, 8, 3. But some of the details are different. So the process for converting a string numeric literal to a value of number type is given here in full. This value is determined in 2 steps. First, a mathematical value, MV, is derived from the string numeric literal. Second, this mathematical value is rounded as described below. The MV of string numeric literal, empty, is 0. The MV of string numeric literal, str white space is 0. The MV of string numeric literal, str white spaciat, str numeric literal, str white spaciat is the MV of str numeric literal. No matter whether white space is present or not, the MV of str numeric literal, str decimal literal is the MV of str decimal literal. The MV of str numeric literal, hex integer literal is the MV of hex integer literal. The MV of str decimal literal, str unsigned decimal literal is the MV of str unsigned decimal literal. The MV of str decimal literal plus str unsigned decimal literal is the MV of str unsigned decimal literal. The MV of str decimal literal, str unsigned decimal literal is the negative of the MV of str unsigned decimal literal. Note that if the MV of str unsigned decimal literal is 0, the negative of this MV is also 0. The rounding rule described below handles the conversion of this signless mathematical 0 to a floating point plus 0 or 0 as appropriate. The MV of str unsigned decimal literal, infinity is 1,010,000, a value so large that it will round to plus. The MV of str unsigned decimal literal, decimal digits is the MV of decimal digits. The MV of str unsigned decimal literal, decimal digits. Decimal digits is the MV of the first decimal digits, plus the MV of the second decimal digits times 10n, where n is the number of characters in the second decimal digits. The MV of str unsigned decimal literal, decimal digits. Exponent part is the MV of decimal digits times 10e, where e is the MV of exponent part. The MV of str unsigned decimal literal, decimal digits. Decimal digits exponent part is the MV of the first decimal digits plus the MV of the second decimal digits times 10n times 10e, where n is the number of characters in the second decimal digits and e is the MV of exponent part. The MV of str unsigned decimal literal, decimal digits as the MV of decimal digits times 10n, where n is the number of characters in decimal digits. The MV of str unsigned decimal literal. Decimal digits exponent part is the MV of decimal digits times 10n, where n is the number of characters in decimal digits and d is the MV of exponent part. The MV of str unsigned decimal literal. Decimal digits is the MV of decimal digits. The MV of str unsigned decimal literal. Decimal digits exponent part is the MV of decimal digits times 10e, where e is the MV of exponent part. The MV of decimal digits. Decimal digit is the MV of decimal digit. ECMA International 2009 45, the MV of decimal digits. Decimal digit is the MV of decimal digits times 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the MV of decimal digits. The MV of signed integer. Plus decimal digits is the MV of decimal digits. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 is 0. The MV of decimal digit. 1 or of hex digit. 1 is 1. The MV of decimal digit. 2 or of hex digit. 2 is 2. The MV of decimal digit. 3 or of hex digit. 3 is 3. The MV of decimal digit. 4 or of hex digit. 4 is 4. The MV of decimal digit. 5 or of hex digit. 5 is 5. The MV of decimal digit. 6 or of hex digit. 6 is 6. The MV of decimal digit. 7 or of hex digit. 7 is 7. The MV of decimal digit. 8 or of hex digit. 8 is 8. The MV of decimal digit. 9 or of hex digit. 9 is 9. The MV of hex digit. A or of hex digit. A is 10. The MV of hex digit. B or of hex digit. B is 11. The MV of hex digit. C or of hex digit. C is 12. The MV of hex digit. D or of hex digit. D is 13. The MV of hex digit. E or of hex digit. E is 14. The MV of hex digit. F or of hex digit. F is 15. The MV of hex integer literal. 0x hex digit is the MV of hex digit. The MV of hex integer literal. 0x hex digit is the MV of hex digit. The MV of hex integer literal. Hex integer literal hex digit is the MV of hex integer literal times 16 plus the MV of hex digit. Once the exact MV for a string numeric literal has been
Well, this is annoying.
type. If the MV is 0, then the rounded value is plus 0 unless the first non-white space character in
I have a macro right here, whatever. I'm calling it here.
the sense defined in 8.5, unless the literal includes str
So it's right here. I call it here.
digits, in which case the number
It takes 0 arguments.
MV of a literal produced by replacing each
I make it log error that defines absent.
of a literal produced by replacing each significant digit after the 20th with a 0 digit and then
With the letter A.
the 20th digit position. A digit is significant if it is not part of an exponent part and it is slipped 0, or there is a nonce arrow.
When I build it,
There is a nonce arrow digit, not in the exponent part. To its right, 0.4 to integer. The abstract operation to integer converts its argument
it says that define as absent.
functions as follows. Let number be the result of calling to number on the input argument. If number is nan, return plus 0. If number is plus 0, 0, plus
A, and then there's a A at the end, whatever.
sign, number, floor, abs, number, 0.5 to 32. Sign 32-bit integer. The abstract operation to int 32 converts its argument to one of 232 integer values in the
Nowhere else in the file is named this. And there's no other files included yet.
functions as follows. 6. Copyright
So it's declared whatever placed right after the macro. But
number is nan, plus 0.
it's only placed once.
Return plus 0. Let pose int be sign, number, floor, abs, number. Let int 32-bit be pose int modulo 200.
So it's supposed to define this keyword, whatever.
Such that the mathematical difference of pose int and k is mathematically an integer multiple of 232. If int 32-bit is greater than or equal to 231, return int 32-bit 232. Otherwise return int 32-bit. Note, given the above definition of int 32, the int 32 abstract operation is idempotent
So inside of here,
that it produced. The second application leaves that value unchanged. Int 32. Int 32 x is
I'm going to define it. So now this is defined.
Preserve this latter property that plus and maps to plus 0. To int 32 maps 0 to plus.
Right here, there's only two of them.
Operation to int 32 converts its argument to one of 232 integer values in the range 0 through 232 inclusive. This abstraction operation functions as follows. Let number be the result of calling to number on the input argument. If number is nan, plus 0, 0, plus, or return plus 0. Let pose int be sign.
This macro is defined here, in place here. So it should be defined over here, which means I should print A and then B, because it enters this macro here first, because it's like enters whatever it's building. I would assume that this will be defined because it calls this macro, and this will be defined after, because it does this first, then this. So it should throw an error on A, not on B. So name this one with a B.
X is equal to int 32 x. For all values of x, it is to preserve this latter property that plus and maps to plus 0. To int 32 maps 0 to plus 0. 0.7 to int 16. Unsigned 6.
So I'm going to test for if not defined.
Converts its argument to one of 216 integer values in the range 0 through 216
So if it's not defined, which it should be, because I'm calling the macro here,
or return plus 0. Let pose int be sign.
applying this macro here. That's this macro. And it has the define here that I'm testing for. So if this is being called first, it should print the define is absent, or like change it to change the macro.
32 in step 4 is the only difference between int 32 and int 16. Int 16 maps 0 to plus 0, 9.8 to string. The
Now it says has entered
its argument to a value of type string according to table 13.
the macro to define it.
Type undefined null boolean number string object. Table 13 to string conversions. Undefined null. If the argument is true, then the result is true. If the argument is false, then the result is false. C9 8 1. Return the input argument no conversion. Apply the following steps. Let prim value be to primitive input argument hint string 2. Return
Underneath it here, it says the define is somehow absent. What even? So since this is macro, it's called before, where it's testing for the define that's in the macro, it should throw an error that says A. So when I run it,
than 0. Return the string concatenation of the string into string m. If m is infinity, return the string infinity. Otherwise, let n, k, and s be integers such that k1, 10k1s, 10k, the number value for s10nk is m, and k is as small as possible. Note that
it says error has entered the macro to define it.
and that the least significant digit of s is not necessarily uniquely determined by these criteria. If kn21, return the string consisting of the k digits of the decimal representation of s. in order, with no leading zeros, followed
Oh no, now it says A. Maybe it's working.
N21. Return the string consisting of the most significant
So now I'm gonna get rid of this warning because it did enter first and stopped it.
point, followed by the remaining K.
So now it should be defined because it literally stated that it entered here first. So like at this point, it should be defined.
Followed by the K digits of the
So I'm gonna run it.
division of S. Otherwise, if K equals 1, return the string consisting
Are you serious? Is it working?
of a case character E, followed by a plus or minus sign according to whether N1 is positive or negative, followed by the decimal representation of the int
Never mind, I guess.
leading zeros. 0. Return the string consisting of the most significant digit of the decimal representation of S, followed by a decimal point, followed by the remaining K1 digits of the
I guess it's working perfectly fine. Well, that was annoying. I don't know what was going on. It wasn't building though. I changed the name. Does this name mess with it somehow?
zeros. Note 1. The following observations may be useful as guidelines for implementations, but are not part of the normative requirements of this standard. Road. If x is any number value other than 0, then to number, to string, x is exactly the same number value as x. The
Why?
determined by the requirements listed in step 5. Note 2. For implementations that provide more accurate conversions than required by the rules above, it is recommended that the following alternative version of step 5 be used as a guideline. Otherwise, let n, k,
So now I'm gonna test if it's defined.
10k, the number of
I changed it to if defined.
unconsistent
So if it's defined, it'll print B whatever to the console.
k is closest in value to m if there are two such possible values of s. Choose the one that is even. Note that k is the number of digits in the decimal representation of s and that s is not divisible by 10. Note 3. Implementers of ECMAScript may find useful the paper and code
I guess it's working.
conversion of floating point numbers. 8. Copyright sign, ECMA International 2009. Gay, David M. Correctly rounded binary decimal and decimal binary conversions. Numerical analysis, manuscript 9010. AT&T Bell.
I'm just gonna leave it because it looks like it's working.
The 30th of November, 1990. Available as http://cm.bell-labs.com/cm/cm/4-10.ps.gz. Associated code available as http://cm.bell-labs.com/netlib/fp/dtour.c.gz and as http://cm.bell-labs.com/netlib/fp/g_fmt.c.gz and may also be found at the various netlib mirror sites. Point 9. To object. The abstract operation to object converts its argument to a value of type object according to table 14. Argument type, undefined null boolean, number, string object. Result, table 14. To object, throw a type error exception. Throw a type error exception. Create a new boolean object whose internal property is set to the value of the argument. See 15.6 for a description of Boolean objects. Create a new number object whose internal property is set to the value of the argument. See 15.7 for a description of number object.
Okay, I figured it out.
Internal property is set
Chatbot lied to me.
a description of string objects. The result is the input argument no conversion. 9.10 check object coercible. The abstract operation check object coercible throws an error if its argument is a value that cannot be converted to an object.
Chatbot told me
15. Argument type, undefined null boolean.
that you can type defined just like in C.
Table 15. Check object coercible result.
I'm gonna ask Chatbot again. So what it printed
return, 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 return. The abstract operation is callable determines if its argument, which must be any ECMAScript language value, is
with symbol defined, which means that defined, not defined. It's not talking about defined. It's because the keyword defined
return false, return false, return false, return false.
is this keyword defined. So it's really confusing.
Rhythm. The internal comparison abstract operation same value.
I'm gonna like scroll up to see if that's what it was.
X and Y ECMAScript language values produces true or false. Such a comparison is performed as follows. If type X is different from type Y, return false. If type X is undefined, return true. If type X is null, return true. If type X is number, then if X is nan and Y is nan, return true. B if X is plus 0 and Y is minus 0, return false. C if X is minus 0 and Y is plus 0, return false. D if X is the same number value as Y, return true. E return false. If type X is string, then return true if X and Y are exactly the same sequence of characters, same length and same characters in corresponding positions. Otherwise, return false. If type X is Boolean, return true if X and Y are both true or both false. Otherwise, return false. Return true if X and Y refer to the same object. Otherwise, return false. 0 executable code and execution contexts. 0.1 types of executable code. There are 3 types of ECMAScript executable code. Global code is source text that is treated as an ECMAScript program.
That's not. I don't know. It's getting stuck, I guess. It's working now.
Text supplied to the built.
I have no clue.
More precisely, if the
I guess this isn't actually a keyword. So Chip, I lied.
script program. The eval code for a particular invocation of eval is the global code portion of that program. Function code is source text that is passed as part of a function body. The function code of a particular function body does not include any source text that is passed as part of a nested function body. Function code also denotes the source text supplied when using the built-in function object as a constructor. More precisely, the last parameter provided to the function constructor is converted to a string and treated as the function body. If more than one parameter is provided to the function constructor, all parameters except the last one are converted to strings and concatenated together, separated by commas. The resulting string is interpreted as the formal parameter list for the function body defined by the last parameter. The function code for a particular instantiation of a function does not include any source text that is passed as part of a nested function body. 0 ECMA International 2009 101 1 strict mode code. An ECMAScript program's syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. When processed using strict mode, the 3 types of ECMAScript code are referred to as strict global code, strict eval code, and strict function code. Code is interpreted as strict mode code in the following
Okay, now chatbot isn't saying defined. So, it said it earlier. If you want to watch. I don't know, I can't watch my own stream. It literally said define was the thing.
is a direct call. C15.
Now it's saying LF is indirectly supported.
Function declaration. Function expression.
What does that even mean? Because I'm using LF.
Code if its function declaration, function expression, or property assignment is contained in strict mode code, or if the function code begins with a directive prologue that contains a use strict directive. Function code that is supplied as the last argument to the built. In function constructor as strict function code if the last argument is a string that, when processed as a function body, begins with a directive prologue that contains a use strict directive. 0.2 Lexical environments. A lexical environment is a specification type used to define the association of identifiers to specific variables and functions based upon the
Is chatbot stupid?
Code. A lexical environment consists of an environment record and a possibly null reference to an outer lexical environment. Usually a lexical environment is associated with some specific syntactic structure of ECMAScript code, such as a function declaration, a with statement, or a catch clause of a try statement, and a new lexical environment is created each time such code is evaluated. An environment record records the identifier bindings that are created within the scope of its associated lexical environment. The outer environment reference is used to model the logical nesting of lexical environment values. The outer reference of a
Doesn't it says elif right here? What does chatbot say? It doesn't support elif. Now I gotta check the documentation. Does it not support elif? Chatbot sucks.
in all lexical environments. For example, if a function declaration contains two nested function declarations, then the lexical environments of each of the nested functions will have as their outer lexical environment the lexical environment of the current execution of the surrounding function. Lexical environments and environment record values are purely specification mechanisms and need not correspond to any specific artifact of an ECMAScript implementation. It is impossible for an ECMAScript program to directly access or manipulate such values. 0, 2, 1 and
It says elif right there.
record values used in this specification: declarative environment records and object environment records. Declarative environment records are used to define the effect of ECMAScript language syntactic elements such as function declarations, variable declarations, and catch clauses that directly associate identifier bindings with ECMAScript language values. Object environment records are used to define the effect of ECMAScript elements such as program and with statement that associate identifier bindings with the properties of some object. For specification purposes, environment record values can be thought of as existing in a simple, object-oriented hierarchy where environment record is an abstract class with two concrete subclasses: declarative environment record and object environment record. The abstract class includes the abstract specification, ECMA International 2009-51, methods defined in Table 17. These abstract methods have distinct concrete algorithms for each of the concrete subclasses. Method has binding.
It even has elif not.
Determine if an environment record has a binding for an identifier. Return true if it doesn't, false if it does not. The string value
As if not and elif not. That's really useful. It says elif right here. This is like other if constructs. If has a counterpart, elif and negative forms. If and elif not.
text of the bound name. V is the value for the binding and may be a value of.
So, I don't know why to ask Chip anything.
Error exception. S is used to identify strict mode references. Get binding value. N. S returns the value of an already existing binding from an environment record. The string value N is the text of the bound name. S is used to identify strict mode references. If S is true and the binding does not exist or is uninitialized, throw a reference error exception. Delete binding. N. Delete a binding from an environment record. The string value N is the text of the bound name. If a binding for N exists, remove the binding and return true. If the binding exists but cannot be removed, return false. If the binding does not exist, return true. Implicit this value returns the value to use as the this value on calls to.
Did Jackbot give me bad information on purpose?
Each declarative environment record is associated with an ECMAScript program scope.
How does it know? Hell if not. I bet that they have Chatbot intentionally give bad info so people will correct it. And then they'll check how many people corrected things and they add it to the training data. So tricking people into training chatbot. Because how the hell does it not know? Give me a bad answer. That's more work when it knows about elif, not and stuff. Because this is like really obscure. I didn't even know this existed.
Track specification methods. Table 18. Additional methods of declarative environment records. Method. Create immutable binding. N. Purpose. Create a new but uninitialized immutable binding in an environment record. The string value n is the text of the bound name. Initialize immutable binding. N. V. Set the value of an already existing but uninitialized immutable binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and is a value of any ECMAScript language type. 52. ECMA International 2009. The behavior of the concrete specification methods for declarative environment records are defined by the following algorithms. 0, 2, 1. 1 has binding. N. The concrete environment record method has binding for declarative environment records simply determines if the argument identifier is one of the identifiers bound by the record. Let envrec be the declarative environment record for which the method was invoked. If envrec has a binding for the name that is the value of n, return true. If it does not have such a binding, return false. 0, 2, 1. 2 create mutable binding. N, D. The concrete environment record method create mutable binding for declarative environment records creates a new mutable binding for the name n that is initialized to the value undefined. A binding must not already exist in this environment record for n if Boolean argument d is provided and has the value true, the new binding is marked as being subject to deletion. Let envrec be the declarative environment record for which the method was invoked. Assert. envrec does not already have a binding for n. Create a mutable binding in envrec for n and set its bound value to undefined. If d is true, record that the newly created
You serious? Chatbot.
binding call 0, 2, 1.
It says that elif was introduced in 2.0. Back in 2007.
Of the identifier whose name is the value of the argument n to the value of argument v. A binding for n must already exist. If the binding is an immutable binding, a type error is
It's 2022. That's the latest one.
mode does not change the meaning of setting bindings in declarative environment records. Let envrec be the declarative environment record for which the method was invoked. Assert. envrec must have a binding for n. If the binding for n in envrec is a mutable binding, change its bound value to v, else this must be an attempt.
Is this not organized by date? No, there's 2024 on here too. I don't know.
The concrete environment record method get binding value for declarative environment records simply returns the value of its bound identifier whose name I, s the value of the argument and the binding must already exist. If s is true and the binding is an uninitialized immutable binding, throw a reference error exception. Let envrec be the declarative environment record for which the method was invoked. Assert.
It's not worth digging into.
Binding for n in envrec is an uninitialized immutable binding. Then, if
I'm pretty sure Chatbot misled me on purpose
reference error exception 4, else.
because it tried to not answer it 3 or 4 times. So, I think everything's working now.
Explicitly designated as being subject to deletion. Let envrec be the declarative environment record for which the method was invoked. If envrec does not have a binding for the name that is the value of n, return true. If the binding for n in envrec is cannot be deleted, return false. ECMA International 2009 53. 4. Remove the binding for n from envrec. Return
I'm gonna try to like glue the tokens again. See if it'll work this time.
value. Declarative environment records always return undefined as their implicit this value. Return undefined. 0, 2, 1, 7 create immutable binding. N. The concrete environment record method create immutable binding for declarative environment records creates a new immutable binding for the name n that is initialized to the value undefined. A binding must not already exist in this environment record for n. Let envrec be the declarative environment record for which the method was invoked. Assert envrec does not already have a binding for n. Create an immutable binding in envrec for n and record that it is uninitialized. 0, 2, 1, 1, 8. Initialize a mutable binding n, v. The concrete environment record method initialize a mutable binding for declarative environment records is used to set the bound value of the current binding of the identifier whose name is the value of the argument n to the value of argument v.
It's not working. I think chatbot lied again.
Envrec be the declarative environment record for which the method was invoked. Assert envrec must have an uninitialized immutable binding.
I'm just going to check the documentation.
To v, record that the immutable binding for n in envrec has been initialized. 0, 2, 1. 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of identifier names that directly correspond to the property names of its binding object. Property names that are not an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property has the value false. Immutable bindings do not exist for object environment records. Object environment records can be configured to provide their binding object as an implicit this value for use in function calls. This capability is used to specify the behavior of with statement 12.10, induced bindings. The capability is controlled by a provide this Boolean value that is associated with each object environment record. By default, the value of provide this is false for any object environment record. The behavior of the concrete specification methods for object environment records is defined by the following algorithms. 0, 2, 1, 2, 1 has binding n. The concrete environment record method has binding for object environment records determines if its associated binding object has a property whose name is the value of the argument n. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Return the result of calling the internal method of bindings, passing n as the property name. 4. Copyright sign, ECMA International 2009. 10, 2, 1. 2. To create mutable binding n, d. The concrete environment record method create mutable binding for object environment records creates an environment records associated binding object a property whose name is the string value and initializes it to the value undefined. A property named n must not already exist in the binding object. If Boolean argument d is provided and has the value true, the new property's attribute is set to true. Otherwise it is set to false. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Assert the result of calling the internal method of bindings, passing n as the property name, is false. If d is true, then let config value be true. Otherwise let config value be false. Call the internal method of bindings, passing n, property descriptor, undefined, true, true, config value, and false as arguments. 0, 2, 1, 2, 3. Set mutable binding n, v, s. The concrete environment record method set mutable binding for object environment records attempts to set the value of the environment records associated binding object's property whose name is the value of the argument n to the value of argument v. A property named n should already exist, but if it does not or is not currently writable, error handling is determined by the value of the Boolean argument s. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Call the L method of bindings with arguments n, v, and s. 0, 2, 1, 2, 4. Get binding value n, s, The concrete environment record method getBindingValue for object environment records returns the value of its associated binding object's property whose name is the string value of the argument identifier, and the property should already exist, but if it does not, the result depends upon the value of the S argument. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Let value be the result of calling the internal method of bindings, passing n as the property name. If value is false, then if S is false, return the value undefined. Otherwise throw a reference error exception 5. Return the result of calling the 0, 2, 1, 2, 5 delete binding n. The concrete environment record method delete binding for object environment records can only delete bindings that correspond to properties of the environment object whose attribute have the value true. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Return the result of calling the internal method of bindings, passing n and false as arguments 0, 2, 1, 2, 6. Implicit this value. Object environment records return undefined as their implicit this value unless their provide this flag is true. Let envrec be the object environment record for which the method was invoked. If the provide this flag of envrec is true, return the binding object for envrec. Otherwise, return undefined. ECMA International 2009 55 102. Lexical environment operations. The following abstract operations are used in this specification to operate upon lexical environments. 0, 2, 2, 1. Get identifier reference, lex, name, strict. The abstract operation get identifier reference is called with a lexical environment's lex, an identifier string name, and a boolean flag strict. The value of lex may be null. When called, the following steps are performed. If lex is the value null, then return a value of type reference whose base value is undefined, whose reference name is name, and whose strict mode flag is strict. Let envrec be lex's environment record. Let exists be the result of calling the has binding n concrete method of envrec passing name as the argument n. If exists is true, then return a value of type reference whose base value is envrec, whose reference name is name, and whose strict mode flag is strict. Else, let outer be the value of lex's outer environment reference. B return the result of calling get identifier reference passing outer, name, and strict as arguments. 0, 2.
The chatbot getting more useless.
Is called with either a lexical environment or null. As argument the following steps are performed. Let env be a new lexical environment. Let envrec be a new declarative environment record containing no bindings. Set env's environment record to be envrec. Set the outer lexical environment reference of env to e. Return env 0, 2, 2, 3 new object environment. E. When the abstract operation new object environment is called with an object.
What even is this? It's so stupid.
Following steps are performed. Let env be a new lexical environment. Let envrec be a new object environment record containing O as the binding object. Set env's environment record to be envrec. Set the outer lexical environment reference of env to e. Return env 0, 2, 3. The global environment. The global environment is a unique lexical environment which is created before any ECMAScript code is executed. The global environment's environment record is an object environment record whose binding object is the global object. 15.1. The global environment's outer environment reference is null. As ECMAScript code is executed, additional properties may be added to the global object and the initial properties may be modified. 0.3 Execution contexts. When control is transferred to ECMAScript executable code, control is entering an execution context. Active execution contexts logically form a stack. The top execution context on this logical stack.
Chatbot sucks.
Execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with.
The common pitfall. The mistake is to use chatbot.
The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever state is necessary to track the execution progress of its associated code. In addition, each execution context has the state components listed in Table 19. Component, lexical.
Wait, I just build.
This binding, Table 19, execution context state components. Purpose, identifies the lexical environment used to resolve identifier references made by code within this execution context. Identifies the
That was it.
record holds bindings created by variable statements and function declarations within this execution context. The value associated with this keyword within ECM.
So earlier, chatbot said to do this. So is that not true for arguments? Because with the argument, that does not work. Hit save.
May change during execution of code within an execution context. In most situations, only the running execution context.
And then it's like not defined.
Is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment, variable environment, and this binding are used with
If I get rid of it,
those components of the running execution context. An execution context
and I define like that, then it glues and makes a token name. Right here, whatever.
It is impossible for an ECMAScript program to access an execution context. 0.
Because now when I build it,
Identifier resolution. Identifier resolution is the process of determining the binding of an
it doesn't throw an error. And it builds.
During execution of ECMAScript code, the syntactic production primary expression identifier is evaluated using the following.
Well, I just lost maybe an hour to figuring out that this is the correct way to glue an argument. Because chatbot told me to do this,
And strict as arguments. The result of evaluating an identifier is always a
and it doesn't work.
component
I think that took like 30 minutes to figure out. Like 30. And this probably took 40 minutes to figure out.
and enters a new execution context.
Chatbot told me you could do this.
Also establishes and enters a new execution context, even if a function is calling itself recursively.
It said you could do if defined, just like in C. That doesn't work either. Because when I build it,
All enters an execution context. The execution context this binding is set. Its variable environment and initial lexical environment are defined, and declaration binding instantiation 10.5 is performed. The exact manner in which these actions occur depend on the type.
it says error symbol defined, not defined. This zoom tool sucks here. Not defined before use. So I thought that it meant what is defined, whatever it is, I didn't know what it was. But it was defined, but it literally meant the keyword defined was not defined. Do you see the confusion? That probably took 50 minutes actually,
Steps are performed when control and
because I built it a whole bunch of times after. I don't even know,
is not being evaluated by a direct call.
because the times after this, I must have messed something up trying to fix it. But it was, I don't know, this was the issue at first. I probably broke something trying to fix it. Then I undid stuff, redid stuff. Now it's working. That was really annoying to try to figure out. Figure out how defined was not defined before use, because its name is defined. I can't get any of the time back, so I'm gonna take a break. I'm gonna try to like define these stupid things, because I think I figured out how to glue the tokens. It looks like it's working. I hope it's working. I don't know. I'll be right back.
Variable or function bindings in the variable environment of the calling context that invoke the eval if either the code of the calling context or the eval code is strict code. Instead, such bindings are instantiated in a new variable environment that is only accessible to the eval code. 0, 4, 3 entering function code. The following steps are performed when control enters the execution context for function code contained in function object f. A caller provided this arg, and a caller provided arguments list. If the function code is strict code, set the this binding to this arg. Else if this arg is null or undefined, set the this binding to the global object. Else if type this arg is not object, set the this binding to object this arg. Else set the this binding to this arg. Let local env be the result of calling new declarative environment passing the value of the internal property of f as the argument. Set the lexical environment to local env. Set the variable environment to local env. Let code be the value of f's internal property. Perform declaration binding instantiation using the function code's code and argument list as described in 0.5. 8. ECMA International 2009. 10.5 Declaration Binding Instantiation. Every execution context has an associated variable environment. Variables and functions declared in ECMAScript code evaluated in an execution context are added as bindings in that variable environment's environment record. For function code, parameters are also added as bindings to that environment record. Which environment record is used to bind a declaration and its kind depends upon the type of ECMAScript code executed by the execution context, but the remainder of the behavior is generic. On entering an execution context, bindings are created in the variable environment as follows using the caller-provided code and, if it is function code, argument list args. Let env be the environment record component of the running execution context's variable environment. If code is eval code, then let configurable bindings be true, else let configurable bindings be false. If code is strict mode code, then let strict be true, else let stri be false. If code is function code, then let func be the function whose internal method initiated execution of code. Let names be the value of func's internal property. B let arg count be the number of elements in args. C let n be the number 0. D for each string arg name in names. In list order do. I let n be the current value of n plus 1, 2. If n is greater than arg count, let v be undefined, otherwise let v be the value of the nth element of args. 3. Let arg already declared be the result of calling env's has binding concrete method passing arg name as the argument. If arg already declared is false, call env's create mutable binding concrete method passing arg name as the argument. V call env's set mutable binding concrete method passing arg name, v, and strict as the arguments. For each function declaration f in code, in source text order do, let fn be the identifier in function declaration f. B let fo be the result of instantiating function declaration f as described in clause 13. C let func already declared be the result of calling env's has binding concrete method passing fn as the argument. D if func already declared is false, call env's create mutable binding concrete method passing fn and configurable bindings as the arguments. E call env's set mutable binding concrete method passing fn, fo, and strict as the arguments. Let arguments already declared be the result of calling env's has binding concrete method passing arguments as the argument. If code is function code and arguments already declared is false, then let args obj be the result of calling the abstract operation create arguments object. 10.6 passing func names args env and strict as arguments. B if strict is true, Then, I call envs create immutable binding concrete method passing the string arguments as the argument. 2. Call envs initialize immutable binding concrete method passing arguments and args obj as arguments. C else, I call envs create mutable binding concrete method passing the string arguments as the argument. 2. Call envs set mutable binding concrete method passing arguments, args obj, and false as arguments for each variable declaration and variable declaration no in D code. In source text order do a let dn be the identifier and d b let var already declared be the result of calling envs has binding concrete method passing dn as the argument. See if var already declared is false. Then, I call envs create mutable binding concrete method passing dn and configurable bindings as the arguments. ECMA International 2009 59. 2. Call envs set mutable binding concrete method passing dn, undefined, and strict as the arguments. 0.6 Arguments object. When control enters an execution context for function code, an arguments object is created unless as specified in 10.5. The identifier arguments occurs as an identifier in the function's formal parameter list or occurs as the identifier of a variable declaration or function declaration contained in the function code. The arguments object is created by calling the abstract operation create arguments object with arguments the function object whose code is to be evaluated. Names a list containing the function's formal parameter names. Args the actual arguments passed to the internal method. Env the variable environment for the function code. And strict a boolean that indicates whether or not the function code is strict code. When create arguments object is called, the following steps are performed. Let len be the number of elements in args. Let obj be the result of creating a new ECMAScript object. Set all the internal methods of obj as specified in 8.12. Set the internal property of obj to arguments. Let object be the standard built-in object constructor. 1.5. 2. 2. Set the internal property of obj to the standard built-in object prototype object. 1.5. 2. 4. Call the internal method on obj passing length. The property descriptor len, true, false, true, and false as arguments. Let map be the result of creating a new object as if by the expression new object, where object is the standard built-in constructor with that name. Let mapped names be an empty list. 0. Let index equals len1, 1. Repeat while index equals 0. Let val be the element of args at 0 origin list position index. B call the internal method on obj passing to string index. The property descriptor val, true, 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 and false as arguments. See if index is less than the number of elements and names. Then, I let name be the element of names at 0 origin list position index. 2. If strict is false and name is not an element of map names, then add name as an element of the list map names. Let g be the result of calling the make arg getter abstract operation with arguments. Name and env. Let p be the result of calling the make arg setter abstract operation with arguments. Name and env. Call the internal method of map passing to string index. The property descriptor g, true, and falses arguments. D let index equals index1, 2. If map names is not empty, then A set the internal property of obj to map. B set the and internal methods of obj to the definitions provided below. 3. If strict is false, then A call the internal method on obj passing call E, the property descriptor, func, true, false, true, and false as arguments. 4. Else, strict is true so 0. ECMA International 2009. AB. Let thrower be the function object. 1. 3. 2. 3. Call the internal method of obj with arguments caller, property descriptor, thrower, false, false, and false. C. Call the internal method of obj with arguments callee, property descriptor, thrower, false, false, and false. 5. Return obj. The abstract operation make arg get called with string name and environment record env creates a function object that when executed returns the value bound for name in env. It performs the following steps. Let body be the result of concatenating the strings return, name, and return the result of creating a function object as described in 13.2 using no formal parameter list. body for function body, env as scope, and true for strict. The abstract operation make argset called with string name and environment record env creates a function object that when executed sets the value bound for name in env. It performs the following steps. Let param be the string name concatenated with the string arg. Let body be the string name equals param with name replaced by the value of name and param replaced by the value of param. Return the result of creating a function object as described in 13.2 using a list containing the single string. Param as formal parameter list, body for function body, env as scope, and true for strict. The called with a property name p performs the following steps. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing p as the argument. If the value of is mapped is undefined, then a b let v be the result of calling the default. If p is caller and v is a strict mode function object, throw a type error exception. Return v c else. Map contains a formal parameter mapping for p, so a return the result of calling the internal method of an arguments object for a non-strict mode function with formal parameters. When called with a property name p performs the following steps. Let desk be the result of calling the default internal method 81211 on the arguments object passing p as the argument. If desk is undefined, then return desk. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing p as the argument. If the value of is mapped is not undefined, then a set desk to the result of calling the method of map passing p as the argument. Return desk. The internal method of an arguments object for a non-strict mode function with formal parameters when called with a property name p. Property descriptor desk, and boolean flag throw performs the following steps. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing p as the argument. Let allowed be the result of calling the default internal method 81211 on the arguments object passing p desk, and false as the arguments. If allowed is false, then if throw is true, then throw a type error exception. Otherwise return false 5. If the value of is mapped is not undefined, then ECMA International 2009-61. If is accessor descriptor, desk, is true, then I call the internal method of map passing p, and false as the arguments. Be else. If desk is present, then call the, and throw as the arguments. 2. If desk is present and its value is false, then call the internal method of map passing p and false as arguments. Return true. The internal method of an arguments object for a non-strict mode function with formal parameters. When called with a property name p and boolean flag throw performs the following steps. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing p as the argument. Let result be the result of calling the default internal method 81211 on the arguments object passing p and throw as the arguments. If result is true and the value of is mapped is not undefined, then I call the internal method of map passing p, and false as the arguments. 5. Return result. Note 1 for non-strict mode functions: the array index, defined in 15.4. Named data properties of an arguments object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the functions. Execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. For strict mode functions, the values of the arguments object's properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 2: the parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly accessible from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note 3: arguments objects for strict mode functions define non-configurable accessor properties named caller and callee which throw a type error exception on access. The callee property has a more specific meaning for non-strict mode functions, and a caller property has historically been provided as an implementation-defined extension by some ECMAScript implementations. The strict mode definition of these properties exists to ensure that neither of them is defined in any other manner by conforming ECMAScript implementations. 1. Expressions. 1.1 Primary expressions. Syntax. Primary expression. This identifier literal array literal object literal expression 1 at this keyword. The this keyword evaluates to the value of the this binding of the current execution context. 2. Copyright sign. ECMA International 2009 111. 2. Identifier reference. An identifier is evaluated by performing identifier resolution as specified in 103.1. The result of evaluating an identifier is always a value of type reference. 1.3 Literal reference. A literal is evaluated as described in 7.8.111. 4. Array initializer. An array initializer is an expression describing the initialization of an array object, written in a form of a literal. It is a list of 0 or more expressions, each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. Array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax. Array literal. Eligenort. Element list. Element list. Eligenort. Element list. Eligenort assignment expression. Element list. Eligenort assignment expression. Elision. Semantics. The production array literal. Eligenort is evaluated as follows. Let array be the result of creating a new object as if by the expression new array, where array is the standard built-in constructor with that name. Let pad be the result of evaluating elision. If not present, use the numeric value 0. Call the return array. The production array literal element list is evaluated as follows. Return the result of evaluating element list. The production array literal element list eligenort is evaluated as follows. Let array be the result of evaluating element list. Let pad be the result of evaluating elision. If not present, use the numeric value 0. Let len be the result of calling the return array. The production element list eligenort assignment expression is evaluated as follows. Copyright sign. ECMA International 2009. 3.1. Let array be the result of creating a new object as if by the expression new array, where array is the standard built-in constructor with that name. Let first index be the result of evaluating elision. If not present, use the numeric value 0. Let init result be the result of evaluating assignment expression. Let init value be jet value. Init result. Call the internal method of array with arguments to string. First int x, the property descriptor, init value, true, and false. Return array. The production element list eligenort assignment expression is evaluated as follows. Let array be the result of evaluating element list. Let pad be the result of evaluating elision. If not present, use the numeric value 0. Let init result be the result of evaluating assignment expression. Let init value be jet value. Init result. Let len be the result of calling call the internal method of array with arguments to string. 32. Pad plus len. And the property descriptor. Init value. True, and false. Return array. The production elision is evaluated as follows. Return the numeric value 1. The production elision is evaluated as follows. Let preceding be the result of evaluating elision. Return preceding plus 1. Note is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 5 Object initializer. An object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property names and associated values, enclosed in curly braces. The values need not be literals. They are evaluated each time the object initializer is evaluated. Syntax. Object literal. Property name and value list. Property name and value list. Property name and value list. Property assignment. Property name and value list. Property assignment. Property assignment. Property name. Assignment expression. Get property name. Function body. Set property name. Property set parameter list. Function body. 4. Copyright sign. ECMA International 2009. Property name. Identifier name. String literal numeric literal. Property set parameter list. Identifier. Semantics. The production object literal is evaluated as follows. Return a new object created as if by the expression new object, where object is the standard built-in constructor with that name. The production's object literal, property name and value list, and object literal, property name and value list, are evaluated as follows. Return the result of evaluating property name and value list. The production property name and value list. Property assignment is evaluated as follows. Let obj be the result of creating a new object as if by t.
Siri, is this working? I don't know. I guess Siri ran out of stuff to read. So like, click Siri text speech, whatever. And YouTube like recommended this video. It actually makes a lot of sense. I have to like get the video. I don't know. I never saw this video before. The YouTube recommended it just out of nowhere. It's spot on though.
Hope you're doing amazing. Let me tell you, retard maxing is the ultimate white pill. And when I say be retarded, I feel like I need to break this down for you. So here's a guide on how to be a retard in the modern day. As my good friend Killian in our High Thermals Brotherhood said, he said, listen, you guys aren't dumb. You have common sense. Retard maxing should be applied very liberally, first off. This is our guide. You use your common sense, but you don't abide by what your parents think. You're not living your life for your parents. You're not living your life to impress other people. You're not going with society standards. That is the essence to retard maxing. The ultimate white pill. You should approach actions 95% of the time with a retarded sense of confidence that whatever you start, you don't see the end. And I know this goes against a ton of self-improvement, ton of self-development advice, but especially these days, you do not need to start something with the end in mind. For instance, YouTube. If you have an inkling of an idea, hey, Eli, I've been thinking about making a YouTube video, but I'm not sure if it's worth the money, if I can make a lot of money.
I don't know. I guess that's what I'm doing, whatever. I'm like retard maxing, I guess. Except I do have an end goal. I don't think having no end goal would have a point. So maybe I'm not 100% retard maxing, but I am maybe 50%. If I did this without a goal, it'd be so depressing. So there is an end to this. Hopefully, only 2 months. Maybe a little bit longer. But there is an end. So I'm gonna get back to this supermassive project that I am oversimplifying. But there is an end. So I'm gonna get back to it and see how much more done I can get today. I literally have a whole program, whatever. In Visual Studio. And I can run it and build it. Because I just played that video. And someone might think I'm joking. I'm like, this is like actually serious. I'm not joking about the engine. So it's building. I don't know. This is a JavaScript engine that I have. I have like the conditions, the operations, whatever, the objects, the trees, not the trees. Well, it's like data trees, whatever. I have the object, the keys, the ints. I don't know. I have everything except for the operations. For those, I unwrapped parts of the macro and tested for like things specifically, but I don't have like overall control flow, and loops can only be so big. because it doesn't reset at the end, so I can't do like a million loops because it just takes some more memory. So that's what I like have to add to the engine when I go through the standard. I have to actually meet the whole standard, and then it's going to survive a million loops. And it doesn't survive a million loops because I didn't need a million loops. But I want to like test some code, my engine against the current engine, and I can't do enough loops to like get a reasonable comparison in performance. So I don't know. It's like there is an engine or whatever. This isn't total retard maxing. Well, now it's not printing because I'm in a loop. I don't know. I did this yesterday. Yesterday, whatever, I proved that x minus, we gotta flip it around. Let's paste this to Notepad. I don't know, yesterday I was like comparing assembly. The Visual Studio, whatever, versus Clang or whatever. Oh, it's still here. And I was like talking about optimization. And I explained that 255 minus any value that's also a power of 2 minus 1 will be the remainder or whatever. So like a subtraction, because math isn't real. It's a defined set of operations and known outcomes based on the patterns and how they're set up to logically be ordered based on whatever. So like math isn't real because, well, it is real, but it depends on context, because this 255 minus chips is the same thing as 255 XOR chips. So that might sound, what do you call it? Retard max, whatever. But if you ask the compiler, you copy this. Well, I knew this trick before I found it out, just doing math or whatever. Because I had a circular buffer and the subtraction, I want to get rid of it, so I replaced it with XOR. But I don't know. I broke down You eventually figured out that you can literally just flip the number to get the remainder, but it breaks down even simpler than this. I don't know, I'll paste it to the compiler and show you. So like saying mass, not real. It's saying you can like replace subtraction in some cases where the left hand side is a power 2 minus 1 and the right hand side is no greater than the set of the numbers at whatever the power 2 minus 1 belongs in, whatever. So when I go to like the compiler, this is online, disassembler, whatever. Put your C code on the left, and then outputs assembly on the right. So I'm going to put in the subtraction and then the XOR whatever, and the compiler is going to back me up to prove that 255 minus chips, since they're both the same type, they're both the same size t to the power of 2 minus 1. Then in this case, mathematically, subtraction is the same as an XOR. But it's even simpler than that, but I'll get to that in a second. Visual Studio was unable to see this connection, but Clang did. So like Clang is a much smarter compiler. So math is real or whatever, but you can replace math with really simple, fast operations in places where the mathematical number or the outcome pattern of that number can be replaced with binary operations, whatever. Okay. I think yesterday something was wrong with the Visual Studio output. Or they updated it, but it did have the wrong flag, so it could have been not optimized. Because now this looks better than what I had yesterday. So anyways, this is what 255 minus chips whatever results is. It's a move and then a not. Because you don't even need to subtract, you don't even need to XOR. Because like I have in my list here, whatever, on the left side, I did 255 minus X. And on the right, I did 255 XOR X. And 0, 255, it all turns out exactly the same. Because 255 or max int of anything, if it's like a ulong, anything that's max int, so if it's like a 64-bit value, or if it's 32-bit, or 16-bit, or 1 byte, it's just 255. When you subtract a number from max int to the power 2, or not max, it doesn't matter, just anything that's power 2 minus 1. Well, you might have to mask the value if it's not a power 2. That's like, that fits in size T register. So you have to count for that also. Anyways, clearly you don't even have to subtract because you can just not the value. You just flip it. You can't negate it because if you make it negative, you're going to subtract 1, then plus 1 or whatever, and then 0 stays 0. But if you negate it or you not it instead, and you just flip the number, you don't even have to do subtraction because it's just the opposite. And the compiler, I guess Visual Studio 2, yesterday, either I didn't set the setting I thought I did, or they updated it since yesterday. I probably forgot to set the setting, the flag here. I thought I set it. But yesterday it like did the subtraction and the XOR. It didn't get to like, it didn't realize that it could just not it, but now it is. So for like this really simple operation, whatever, Visual Studio outputs this. And then Clang outputs this. So they did Visual Studio and Clang. They both realized that it could not, the value, it doesn't have to subtract or even XOR. So the compiler caught up on that trick, but there's a bunch of other tricks that I'm pretty sure it doesn't know that I know. So when I write my assembly, I can like account for all these little tricks that make it faster. Which is why, I don't know, whatever. So like, anyways, Visual Studio gets the byte from the stack, which is going to be slower than passing it in a register, like in Clang. So even like, it's like 2 instruction example, Visual Studio still fails because they use their common calling convention, where it always goes on the stack, and they have to fetch it from the stack. They gotta do a load here. They could do stack pointer -4 just to get the byte. While Clang is able to use EDI to pass it in. That's their convention. And then they assign it the EAX, and they do not. So like even here, I could beat the compiler because I'm not following the convention. I could change it if I want. So I could just do like this. Which would give me 1 instruction. So like even in this case, since I'm not the compiler, I can figure out whatever the compiler does bad and make it twice as fast. So I don't know, at least twice as fast. So that's what I'm going to test after I get like I don't know, the engine's not running right now. Later. So like I'm gonna test assembly whatever after I get this macro set up and all the tokens are gluing and all the defines are working, and I get it to output everything to this window, a little list and stuff, so I can like view all the numbers, compare the timing. I don't know. So that's what I get back to. I shouldn't have got off track. That's distracting. So I don't know, I'm gonna get back to that. I gotta like set up these defines and stuff and template this to make more macro lists. So I'm gonna get to that or whatever. And get Siri reading documentation stuff. So like there is a goal to this. This isn't endless. There's a goal. How long it'll take? Hopefully a lot quicker than I think it will. But there is an end. This engine's gonna be really, really fast. Like, for real, for real. It's gonna be so freaking fast. And when I'm done with the engine, I can tell everyone, suck it. Because it's like the ultimate W. Just freaking. No one else can do this. Good luck if you try. And I said try because I highly doubt anyone else could figure out how to optimize assembly and apply it to JavaScript. Because everyone knows how to program a high level language, but nobody knows how to program at low level. And we like know both of them. I don't know. I'm pretty sure I have like a really, really clear advantage in this thing when I'm done. It's be fast as fuck.
The environment record is a declarative environment record that is used to represent the outer scope of an ECMAScript module. In addition to normal mutable and immutable bindings, module environment.
I like to see like open source engines release something after I release mine to like compete. There's like no way any engine could compete because it's gonna be so slow compared to this thing. It'd be so freaking fast.
Binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms: 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert. S is true. Assert. envrec has a binding for n. If the binding for n is an indirect binding, then let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2 true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode code 9. 1, 1, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method. Purpose. Create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding. Return the value of this environment records this binding. ECMA International 2024 149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C13, 5, 1, 1, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called: return true, 1, 1, 5. Forget this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called: return undefined, 1, 1, 5, 5. Create import binding, n, m, n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called: assert. envrec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused. 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record. Unresolvable. Name. Strict. This value. Empty. Let exists be env has binding. Name. If exists is true, then a return the reference record. env. Name. Strict. Empty. Else. 150. ECMA International 2024. Note, module environment records always provide this binding. AB. Let outer be env. Return. Get identifier reference. Outer. Name. Strict. 9. 1. 2. To new declarative environment. E. The abstract operation new declarative environment takes argument D, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment. O. W. E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment. F. New target. The abstract operation new function environment takes arguments F, an ECMAScript, PT function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical, else. Set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment. G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let objrec be new object environment. G. False. Null. Let dclrec be new declarative environment. Null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env, ECMA International 2024 151, 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMAScript code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name. Value type. Meaning. Outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names. A list of private names. The private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1. To resolve priva, T identifier, privy env, identifier. The abstract operation resolve private identifier takes arguments privy a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy for each private name pn of names. Do if pn is identifier, then I return pn. Let outer privy be privy. Assert outer privy is not null. Return resolve private identifier. Outer privy identifier. Point 3 realms. Before it is evaluated, all ECMAScript code must be associated with the realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMAScript global environment, all of the ECMAScript code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24:52, copyright sign, ECMA International 2024. Table 24. Realm record fields. Field name. Agent signifier. Intrinsics. Global object. Global env. Template map. An object or undefined value. An agent signifier. A record whose field names are intrinsic keys and whose values are objects. A global environment record. A list of records with fields. A template literal. Parse node. And v. An array. F. The agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm. A list of records with fields are a string and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module 16.2.1.8. Note 1: in realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated value is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.3. To create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec. realm rec, return unused, 3.3 set realm global object, realm rec, global obj, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then a let intrinsics be realm rec, be set global obj to ordinary object create, intrinsics assert, global obj is an object. If this value is undefined, set this value to global obj, set realm rec to global obj, let new global env be new global environment, global obj, this value, set realm rec to new global env, return unused, 3.4 set default global bindings, realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec for each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desk be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Definep, property or throw, global, name, desk, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMAScript implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMAScript resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMAScript features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMAScript code execution contexts have the additional state components listed in Table 26. Tab, the 26. Additional state components for ECMAScript code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. It is impossible for ECMAScript code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let X be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding. Name. env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert. env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference. env. Name. Strict. 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment. 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has a this binding. 4.4 Resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Return env rec get this binding. 4.5 Get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Assert. env rec has a field. Return env rec. 4.6 Get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5. Let current realm be the current realm record. Return current realm jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMAScript code. Their implementations must conform to the following requirements at some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty. The implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note: one host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAScript code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields. 5.2 Host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note: two host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note: the WHATWG HTML specification https://html.spec.wg.org/ for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback empty. ECMAScript hosts that are not web browsers must use the default implementation of host make job callback, 5.3 hosts call job callback v arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record v an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call job callback v arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job.
I finally got a macro list, whatever. So now I can
Find abstract operate
oh, I need some water.
arguments job, a job abstract closure, and realm.
Save it back up.
It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract
I can delete the old stuff.
scheduled without additional constraints, such as priority and ordering. An implementation of host enq generic job must conform to the requirements in 9.5 host enq promise job, realm, the host defined apps.
Now I have this macro, whatever, called like, whatever the name is. It's template define. The name doesn't even matter. It's just a name. Passes in one argument. I just glue to the end of it this tag, whatever.
Otherwise, to be scheduled with equal priority to
Now, so now this is defined here. It's called the template define macro. Pass in this tag. So now everything related to
must perform implementation defined steps such that execution is prepared to evaluate ECMAScript code at the time of job's invocation. Let script or module be get active script or
everything related to this list is like macrotized.
each on job is invoked. The implementation must perform
And now I can take this.
Such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same
Duplicate it twice.
job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that
Go over my notes, whatever.
is scheduled and run. For example, promise
Paste it here.
calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that host
And then now, this template, the define whatever, the defines for this tag whatever,
by new promise resolve thenable job.
this is added to the end of the define name.
The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler
So this like does 0 to 15. I just like inlined it. So now I have to make it a loop or whatever.
current realm recorded that
So it won't take up so much space in the file.
is null, no
So right now it goes 0 to 15.
created and no new ECMAScript
It's macrotized.
objects will be created. The WHA
Oh, I still have to pass in another argument. I have to make this 2.
on //
I have to pass in to pick the type. So he's going to print binary word or hexadecimal word.
ability to
Hexadecimal word.
https://html.spec.wg.org/
And I can add whatever more like formats that I need to this list, whatever.
seconds. The host-defined abstract operation host enqueue timeout
So I want log,
a job abstract closure
position of highest bit, macro,
seconds, a non-negative
or like list, collection, whatever. That's what's in the program right now.
in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of
That's this 0 to 15, whatever.
9.5, 9.6 initialize host-defined realm.
Now I need to pass in the type that I want to format the values as. So put like a comma.
It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function
So this is binary, whatever.
realm of new context to realm. Set the script or module of
Obviously, it's like 0 and 1. I'm pretty sure everyone knows what binary is. Not how to read it, but like the concept of 0 and 1 is really basic.
global object.
So it's clearly binary. So it's going to be the first type for this list. It's binary.
Indicating that an ordinary
So now it's going to call this template defined macro.
is binding in realms global.
It's going to give it this name to tag it. And it's going to pick this enum option. So it's this macro. Let's pick this enum option, whatever. And prefixes with Y, and I'll print as binary.
JB. Set default global bindings.
And then for the benchmark for wall time, I'm going to want to print
Return unused. 0.7 agents. An agent comprises a set of ECMAScript execution contexts. An
hexadecimal, but I want to print quad because it's 64-bit.
record and an
I think quad 64-bit. So I have to add another option to this list of options.
executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an
So I add another option below this one called quad. It'll take up, or it'll print whatever, 8 bytes instead of just 2.
field is true. Note when some web browsers share a single
I think this is like defined for 4 bytes, but I'm only printing 2. Oh, and I gotta adjust this one.
International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps.
So now I have 3 defines for 3 lists, separate lists, 1 list to log the position of the highest bit
Context.
as binary numbers.
Signifier is a globally unique opaque value used to identify an agent. Table 29, agent record fields. Field
So this is going to log what it is right now.
in the default
I still have to make an option to pass in a header.
needed by the algorithm's get value from
So I can make another header that says like log wall time or whatever, and log cycle count.
value has been observed it cannot change. Can block. A boolean determines whether the agent can block or not.
So that, I don't know, I just explained it. Now I add these 2 options to log the wall time and CPU cycles.
True if atomic operations on 1 byte values are lock-free. False otherwise is lock-free 2. A boolean. True if atomic operations on 2 byte values are lock-free. False otherwise is lock-free 8. A boolean. True if atomic operations on 8 byte.
And then I'll put those lists underneath it here. If there's not enough room in this window, I'll have to figure out how to put it to a file. I could put it to the console, but I don't know. A file sounds better. And then I can speed test.
Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMAScript implementations. There is no field 4-byte atomic operations are always log-free.
I can speed test
Atomic
if the mic was gonna work.
lock. The operation is not lock-free. Lock-free does not
The mouse isn't working.
depend on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free
And then I can speed test.
received atomicity of non-atomic accesses of size n.
Disassembling stuff, and I can get the dwell time and the cycle count, how many cycles, whatever instruction cycles to complete. So I can get like a better evaluation of which one's more efficient and faster. So I'll compare Visual Studio to like Clang, then to my assembly.
Signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps.
And I'll just like print all three lists, whatever.
7.2 agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean.
So I'll try to like build it. It should still build. Even though I'm not using these lists, the other two yet.
Return AR agent clusters. Note in some environments it may not be reasonable for a given agent to suspend.
I'll like delete the output to make sure it builds.
Reasonable to disallow suspending a document's main event handling thread, while still allowing workers
And then it built.
suspend. An agent cluster is a maximal set of
And then it built that one too. So double click.
agent cluster. All agents within a cluster must have the same value for the field.
And it looks like it still works.
Agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective.
So I'm gonna get some more water, whatever.
Activate, stop forward progress, or activate, resume forward progress.
And then I think I'm like
Does so.
try to make this part into a macro.
Activated indefinitely. Note 1 programs within different agents may share.
So that 1 to 15, whatever, it'll loop and generate it.
There may be agents that can
Because typing it up by hand is ridiculous. I need to like define it once, pass it in, so it can be all contained inside of a single macro.
after which A terminates and B creates agent C. The 3 agents are in the same CL. Aster if A could share some memory with B and B could share some memory
And then like once it's all moved into like a single macro,
of it becomes hard.
I can call it to like print the list. So instead of having all this stuff, all expanded stuff.
The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated.
I can make like a macro called print list or something.
I'm independent of documents and any windows were allowed to
I just gotta tag the prefix or the postfix, I guess, because glued to the end. Glued to the end. I need some water. My voice is cracking. So I'll make a macro called print list inside of the macro that's called to define the macros with this postfix name. I can simply paste it,
implication of the restriction is
and then this macro here to log position highest bit.
the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of
This will be able to replace all of this.
strategies, either terminate all the agents in the cluster.
So the whole thing will be gobbled up inside of this macro. I have to look at it, and everything's going to be pre-computed.
With the terminate
And I do that for these two lists.
to identify the agent that was terminated, each of the following specification values.
And then I'm going to run it. It'll build. It'll simply just output all 3 lists. This message box. It's like super clean, super simple then. If I need to make a new list to print some other list of parameters, whatever.
Execution is an empty candidate execution.
Then I simply just go up here, copy, paste. I pick whatever type it needs to be. I give it a name.
Of that type of termination are operating systems or users terminating.
So like, I don't know.
The embedding itself terminating an agent that is running in process with the other agents when per.
I'll name it something different like potatoes in the bag.
In an agent class to share the same candidate execution in its agent records field. The candidate execution is a specification mechanism.
I don't know. So like whatever this list has, I'll give it a type. Down here, copy this,
Forward progress for an agent to make forward
paste it,
step according to this specification. An agent becomes blocked when it's running execute
and then I would print that list after these three.
external event.
And it's that simple. I still have to add more arguments. So after these,
Agent is one that is not blocked. Implementations must ensure that every unblocked agent with a
I'm gonna have to add like whatever prefix someone like tag to the header.
executing thread. One agent eventually makes forward progress. ECMA International 2024 163, an agent does not cause enough.
So like this one prints result position bit. So the lists, I have a print separate header. So I still gotta pass it in.
101 objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak
That's defined here.
time. When weak ref prototype deriv is called, the referent, if undefined, is not, so that subsequent
So I don't know.
also return the same value. This list
I just give each list a header.
kept objects abstract operation. When an object or symbol which is registered with the finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made after synchronous ECMAScript execution completes. The finalization registry cleanup
It's like benchmark, well time, a log, how long it took to complete in real time.
clear kept objects or cleanup finalization registry may interrupt synchronous ECMAScript execution. Because hosts may assemble longer, synchronous ECMAScript execution runs the specification
And then I'll list, I'll like log whatever the CPU cycle count was. And then I can like compare real time, but also take into account cycle count for how many cycles the CPU took. Because the CPU cycle time is not the same as real time. It's complicated.
may free up held values. Reduce
And after that, I can like finally
for some set of object
test some stupid assembly
hypothetical weak ref oblivious execution with respect
against my assembly.
by the abstract operation.
And I'll have a better idea of like
Element of S always returns
what's worse, worse and what's better, what's worth my time, what I need to optimize, what I shouldn't optimize, what's faster, what's not, what I need to check for. I don't know. I can think about that as I like parse the rest of the program,
that a weak ref itself does
because I still need to finish converting the JavaScript mechanics that I have right now from 32-bit to 64-bit, so I can go through
assume V's liveness, which would be circular reasoning.
so I can go through a standard
Niceness is defined on sets of objects or symbols instead
and update
for cycles. If it were defined on
the mechanics to like meet the standard, the older one, 2009.
live, even though its identity
And I gotta add the rest of the mechanics I don't have.
note
And once I go through the 24 standard after the 2009 standard,
if every set contains
then I'll have a full JavaScript engine
objects
entirely in C and handwritten x86, 64, and ARM 64 assembly. I need some water.
With respect to S that observe.
So basically, I'm gonna try to just...
The second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak.
I just deleted the whole thing, didn't I?
May be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live...
So, I'm gonna take a break. I'll come back. Back, whatever. My throat is so dry. And then, I'm gonna macrotize this. Or try. I'll spend like 20 minutes. If it takes too long, I'll finish up tomorrow. Need some water. And if my voice cracks again, I don't know, I can't take it. I'll get some water. I'm almost done. I just gotta print these stupid lists.
Registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty? 2.
I don't think I can reuse any of this for like the real engine. I'll just keep the stuff for debugging.
N Q.
I'll like rewrite stuff. I don't know. I'll BRB.
A L I Z.
I have to run it. Make sure it works still.
Capital R E G I S T R F G. C for each weak map such that map.
And it looks okay.
Set such
Unless it didn't build, but it looked like it did.
set whose value is value.
And it looks like the time matches.
24165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding
So I'm pretty sure built. I'll BRB.
observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H O S T capital E N Q U E U E capital F I ration set function length takes arguments f, a function object, and length, a non-negative int ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f. Length. Property descriptor. Length. False. Enumerable. False. True. Return unused. 0, 2, 1, 1. Capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I func arguments list. The abstract operation capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I takes arguments func, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a for binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions twinity. Alize 5. Let arguments object needed be true. 6. If func is lexical, then a note arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then if function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. D assert, the variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared env has binding. Param name. B note, early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. C if already declared is false, then I perform env create mutable binding. Param name. False. 2. If his duplicates is true, then perform env initialize binding. Param name. Undefined 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create and mapped arguments object arguments list. B else. I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter. Any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true. Then I perform env create immutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. Else, I perform env create mutable binding, arguments, false. Perform env initialize binding, arguments. F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then a perform iterator binding initialization of formals with arguments iterator record and undefined. 26. Else a perform iterator binding initialization of formals with arguments iterator record and env. 27. If his parameter expressions is false, then a note, only a single environment record is needed for the parameters and top-level vars. B let instantiated var names be a copy of the list parameter bindings. C for each element n of var names. Do I if instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding, n, false. Perform env initialize binding, n, undefined. D let var env be env. 28. Else, a note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var env be new declarative environment, env. C set the variable environment of callee context to var env. D let instantiated var names be a new empty list. E for each element n of var names. Do I if instantiated var names does not contain n, then ECMA International 2024 183. 1. Append n to instantiated var names. Perform var env create mutable binding, n, false. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined. 4. Else, a let initial value be env get binding value, n, false. Perform var env initialize binding, n, initial value. Note, a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note, an xb, 3, 2, 1 adds additional steps at this point. 0. If strict is false, then a let lexenv be new declarative environment, var env. B note, non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexenv be var env. 2. Set the lexical environment of callee context to lexenv. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element d of lex declarations, do a note, a lexically declared name cannot be the same as a function generator declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of d. Do I if this constant declaration of d is true, then perform lexenv create immutable binding, dn, true 2. Else perform lexenv create mutable binding, dn, false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexenv and private env. C perform var env set mutable binding, fn, fo, false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object, It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1. A built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2.0.2.3.5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1.0.3.1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 1.0.3.2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 1.0.3.1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f. This arguments list, undefined 1.0.3.2, arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in call or construct, f, uninitialized, arguments list, new target 1.0.3.3 built-in call or construct, f. This arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, and new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized, that this value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. and returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note: when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null, 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4b. Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to and Table 31, internal slots of bound function exotic objects. Internal slot type description bound target function a callable object the wrapped function object bound this an ECMAScript language value the value that is always passed as this value when calling the wrapped function. Bound arguments a list of ECMAScript language values a list of values whose elements are used as the first arguments to any call to the wrapped function. 186. ECMA International 2024 10411. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target. Return. Construct, target, args, new target 0, 4, 1, 3 bound function create tar get function bound this bound args The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMAScript language value, and bound args, a list of ECMAScript language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1.0.4.1.1. If this constructor, target function, is true, then a set obj as described in 1.0.4.1.2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys, C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every own property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024-187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desk. The internal method of an array exotic object takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desk. Else if p is an array index, then a let length desk be ordinary get own property a length b assert is data descriptor length desk is true c assert length desk configurable is false d let length be length desk e assert length is a non-negative integral number f let index b 32 p g if index length and length desk is false, return false. H let succeeded b ordinary define own property a p desk I have succeeded is false, return false. J if index length, then I set length desk index plus 1 2 set succeeded to ordinary define own property a length desk 3 assert succeeded is true k return true return ordinary define own property a p desk 0 4 2 to array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232.1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1.0.4.2.1. Perform ordinary define own property a length property descriptor length true false false return a 0 4 2 3 array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array, original array. If this array is false, return array create, length. Let C be get, original array, constructor. If this constructor, C, is true, then 88. ECMA International 2024. Let this realm be the current realm record. B let realm be. Get function realm. C. See if this realm and realm are not the same realm record. Then, I have same value. C. Realm is true. Set C to undefined. If C is an object, then I set C to get C. Add at species. B if C is null, set C to undefined. If C is undefined, return array create length. If this constructor C is false, throw a type error exception. Return construct C length 0 4 2 4 array set length A desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary define known property A length desk. Let new len desk be a copy of desk. Let new len be 32 desk. Let number len be the number desk. If same value 0, new len number len is false, throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property A length. Assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return ordinary define known property A length new len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else. A note. Setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be ordinary define known property A length new len desk. 6. If succeeded is false, return false. 7. For each own property keep P of a such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded B A P B. If delete succeeded is false, then I set new len desk to 32 P plus 1 2. If new writable is false, set new len desk to false. 3. Perform ordinary define known property A length new len desk. 5. Return false. 8. If new writable is false, then assert succeeded to ordinary define known property A length property descriptor false. B. Assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations. and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1, 0, 4, 3, 1. P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property S, P. If desk is not undefined, return desk. Return string get own property S, P. 0, 4, 3, 2. P. Desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property S, P. If string desk is not undefined, then a let extensible be S. Be return as compatible property descriptor, extensible, desk, string desk. Return ordinary define own property S, P, desk 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O. Assert str as a string. Let len be the length of str for each integer I such that 0 len, in ascending order. Do a append to string I to keys for each own property key P of O such that P is an array index and to an integer or infinity P len in ascending numeric index order. Do a append P to keys for each own property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024. 8. For each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do a append P to keys. 9. Return keys 0, 4, 3, 4 string create. Value. Prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length, property descriptor, length, false, enumerable, false, false. Return S, 0, 4, 3, 5 string get own property S, P. The abstract operation string get own prop, RTY takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be S. Assert str as a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r, index plus 1, 1. Return the property descriptor, result str, false, true, false, 0, 4. 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An argument's exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an argument's exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed and create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 201336 to identify them as such. Note 1: while creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an argument's exotic object. ECMA International 2024 191. Note 2: the integer index data properties of an argument's exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the argument's object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3: the parameter map object and its property values are used as a device for specifying the argument's object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note: for ordinary arguments, objects define a non-configurable accessor property named callee which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note 5: ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor. 0441p. The internal method of an argument's exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, args p. If desk is undefined, return undefined. Let map be args. Let mapped be has own property, map p. If is mapped is true, then a set desk to get map p6. Return desk 0442p. Desk. The internal method of an argument's exotic object args takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args. Let is mapped be has own property, map p. Let new arg desk be desk. If is mapped is true and is data descriptor, desk is true. Then, if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to get map p. Let allowed be ordinary define own property, args p. New arg desk 92. ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desk, is true, then I perform map p. Be else if desk has a field, then assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map p desk false 2. If desk has a field and desk is false, then perform map P8. Return true 0, 4, 4, 3. An ECMAScript language value or a throw completion. It performs the following steps when called. Let map be args. Let is mapped be. Has own property. Map P. If is mapped is false, then a return. Ordinary get args P. Receive 4. Else a assert. Map contains a formal parameter mapping for P. P return. Get map P 0, 4, 4, 4. If same value args receiver is false, then a let is mapped be false. Else a let map be args b let is mapped be. Has own property map P. If is mapped is true, then a assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable. B perform set map P V false return. Ordinary set args P V receiver 0, 4, 4, 5 P. The internal method of an argument's exotic object args takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args. Let is mapped be. Has own property map P. Let result be. Ordinary delete args P. If result is true and is mapped is true, then a perform map P5. Return result. ECMA International 2024 193 10 4 4 6. Create and mapped arguments object arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create. Object prototype set obj to undefined. Perform define property or throw obj length property descriptor len true enumerable false true. Let index be 0. Repeat while index len a let val be arguments list. Index b perform create data property or throw obj to string index val c set index plus 1. Perform define property or throw obj at iterator property descriptor array prototype values true false true. Perform define property or throw obj callee property descriptor throw type error false false. Return obj 0 4 4 7. Create mapped arguments object func formals arguments list env. The abstract operation create mapped arguments object takes arguments func an object formals a parse node arguments list a list of ECMAScript language value s and env an environment record, and returns an argument's exotic object. It performs the following steps when called. Assert formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0 4 4 1. Set obj is specified in 1 0 4 4 2. Set obj is specified in 1 0 4 4 5. Set obj to object prototype 0. Let map be ordinary object create null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0 5. Repeat while index len a let val be arguments list. Index b perform create data property or throw obj to string index val c set index plus 1 6. Perform define property or throw obj length property descriptor len true false true 7. Let map names be a new empty list. 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names. 2. If index len, then let G be make arg getter name env. Let P be make arg setter name env. Perform map to string index property descriptor get G false true. Set index to index 1 20. Perform define property or throw obj add at iterator property descriptor percent array prototype values percent true false true 1. Perform define property or throw obj callee property descriptor func true false true 2. Return obj 0 4 4 7 1. Make arg getter name env. The abstract operation make arg getter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A. Return env get binding value name false. Let getter be create built-in function getClosure 0. Note: getter is never directly accessible to ECMAScript code. Return getter 0 4 4 7 to make arg setter name env. The abstract operation make arg setter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters value that captures name and env and performs the following steps when called. A. Return env set mutable binding name value false. Let setter be create built-in function setClosure 1. Note: setter is never directly accessible to ECMAScript code. Return setter 0 4 5. Typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0 4 5 1 p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p b. If numeric index is not undefined, then I let value be typed array get element numeric index. 2. If value is undefined, return undefined. 3. Return the property descriptor value true true true. Return ordinary get own property p. ECMA International 2024 195 10 4 5 2 p. The internal method of a typed array O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p b. If numeric index is not undefined, return as valid integer index numeric index. Return ordinary has property p 0 4 5 3 p. Desk. The internal method of a typed array O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p b. If numeric index is not undefined, Then, if as valid integer index, numeric int x is false, return false. 2. If desk has a field and desk is false, return false. 3. If desk has an field and desk is false, return false. 5. If as accessor descriptor desk is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element. Numeric int x, desk 7. Return true. Return. Ordinary define known property. P desk 0, 4, 5, 4. If P is a string, then let numeric index be canonical numeric index string P be. If numeric index is not undefined, then I return typed array get element. Numeric index 2. Return. Ordinary get. P receiver 0, 4, 5, 5. If P is a string, then let numeric index be canonical numeric index string P be. If numeric index is not undefined, then if same value receiver is true, then perform. Typed array set element. Numeric int x v return true. 2. If as valid integer index numeric int x is false, return true. Return. Ordinary set. P v receiver 96. ECMA International 2024 10456 P. The internal method of a typed array takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then let numeric index be canonical numeric index string P be. If numeric index is not undefined, then if as valid integer index numeric int x is false, return true, else return false. 2. Return. Ordinary delete. P 0, 4, 5, 7. The internal method of a typed array takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy st. Let keys be a new empty list. If it's typed array out of bounds, tar record is false, then let length be typed array length. Tar record be for each integer I such that 0 length in ascending order. Do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do I append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do I append P to keys. 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O B J. Order. The abstract operation capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S takes arguments obj, a typed array, and order, sexist or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj if is detached buffer is true. Then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length, buffer, order, return the typed array with buffer witness record. Obj, byte length, 0, 4, 5, 1, 0 typed array create. Prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1, 0, 4, 5, 1. Set A is specified in 1, 0, 4, 5, 2. Set A is specified in 1, 0, 4, 5, 3. Set A is specified in 1, 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1, 1 typed array byte length. tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If is typed array out of bounds, tar record is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size.
Now it finally generates a list or whatever. It expands at assembly time, compile time, whatever time before the program runs. So I just need to copy whatever I did for this string, the formatting, paste it into the macro, but will the label be defined more than once if it's in the loop? Or will the label be, I don't know, I guess I'll find out. If it is, it's gonna suck. So now it's gonna print whatever it's printing right now. And tomorrow I can like finish up this stupid thing, have templated and output the other list or whatever. It's like the list for like the wall clock time that took to complete when I test the assembly and stuff. Studio assembly on the left. When I test the Visual Studio assembly and the Clang assembly, and chatbot made this, but it's not the same thing. I don't know. I can test whatever I want to test, check the speeds and stuff, but I'm like 100% sure that this by Microsoft is going to be much slower than this by Clang. Possibly not, because conditional moves, they have an overhead. So I don't know. This will probably still be faster than this. If it's not, I'll be really surprised. There's no way that this is faster. But I'll compare it to my assembly too. I don't know which test this was. Was this a subtraction one? I don't know. Whichever test this was, I got a bunch of stuff to test. And I'll print the actual like execution time in real time. And look at like the cycle time too. I'll print it all to this box until this box can't hold everything that needs to be printed. Then I'll have to like print it to a file. I don't want to print it to the console because I hate the console. It's annoying to work with. So I'll just print everything to file, whatever. But not until I run out of space. So like as long as I have enough space to like print the result in the time tests, like the actual like time it takes to complete, and then like the cycle count too. If I have enough space, I'm good. If not, let's print a file. But that's gonna take more time. And talking takes time too. So I'm gonna like stop talking. I'm gonna like move this macro stuff and put it into the loop. Get it running, and I'm done for today. I still have to pass in the header for the macro. I don't know, I'm just gonna do this for now. And I feel like I actually like accomplished something, because every day's been like getting teeny bits of stuff done. I don't know, whatever. But I really didn't accomplish anything, because it's just like doing the same thing you did, except now it's like wrapped up in a macro, so it's templated. So at least I can like template it and simply like just paste it to make more lists or whatever. So I don't know. I'm gonna like finish this up. That'll be done for today. The code that Visual Studio makes. I'm pretty sure it's like the worst compiler. I don't know, that'll be easy to beat. To write faster assembly for. It's Visual Studio. It sucks. And Chatbot. I think Chatbot made code that doesn't even work. So I'll try Chatbot code too. Super fun stuff. How can we like finish up or whatever? Get to print the list. And template the macros, whatever.
human prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1 0, 4, 5, 1. Set A is specified in 1 0, 4, 5, 2. Set A is specified in 1 0, 4, 5, 3. Set A is specified in 1 0, 4, 5, 6. Set A is specified in 1 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1 1 typed array byte length. tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1 2 typed array length. tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array out of bounds. tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert byte length is not detached. Return floor. Byte length. Byte offset. Element size 0, 4, 5, 1 3 is typed array out of bounds. tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert is detached buffer. O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else a let element size be typed array element size. O be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length, or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments O, a typed array, and index, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, index, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If this typed array out of bounds, tar record, is true, return false. Let length be typed array length, tar record. If R, int x, 0 or R, int x, length, return false. Return true. 0, 4, 5, 1 5 typed array get element. O. Index. The abstract operation typed array get element takes arguments O, a typed array, and index, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If as valid integer index, O, int x, is false, return undefined. Let offset be O. Let element size be typed array element size. O. Let byte index in buffer be R. Int x, element size plus offset. Let element type be typed array element type. O. Return get value from buffer. O. Byte index in buffer. Element type. True. Unordered. 0, 4, 5, 1, 6 typed array set element. O. Int x. Value. The abstract operation typed array set element takes arguments O, a typed array, int x, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be. To big int, value. Otherwise, let num value be. To number, value. If as valid integer index, O, int x, is true, then a let offset be O, b let element size be typed array element size. O, c let byte index in buffer be R, int x, element size plus offset. D let element type be typed array element type. O, e perform set value in buffer. O, byte index in buffer. Element type, num value. True, unordered, return unused. ECMA International 2024 199, 10, 4, 5, 1, 7 is array buffer view out of bounds. O, the abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, sexy S, T, B return is view out of bounds, view record. Let tar record be make tie, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, E, C, O, R, O, sexy ST, return is typed array out of bounds, tar record. 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module, C16, 2, 3. There is a one-to-one correspondence between the string keydown properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string valued own property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare f and 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0 4 6 5. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary get own property O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor value true, true, false. 0 4 6 6. P. Desk. The internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define own property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is accessor descriptor desk is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value desk. Current. Return true. 0 4 6 7. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O. P. Let exports be O. If exports contains P, return true. Return false. ECMA International 2024 201 1 0 4 6 8. If P is a symbol, then a return ordinary get O. P. Receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M resolve export. P. Assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a return get module namespace. Target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception. 2. Return target env get binding value. Binding true 0 4 6 9. The internal method of a module namespace exotic object takes arguments P, a property key, V, an ECMAScript language value, and receiver, an ECMAScript language value, and returns a normal completion containing false. It performs the following steps when called. Return false 1 0 4 6 1 0. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return ordinary delete O. P. Let exports be O. If exports contains P, return false, return true, 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pairs arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 104612 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let n be make basic object internal slots list. Set m's essential internal methods to the definitions specified in 1046. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare f. And set m to sorted exports. Create own properties of m corresponding to the definitions in 28.3. Set module to m 0. Return m 0, 4, 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument V, an object or null, and returns either a normal completely on containing a boolean or a throw completion. It performs the following steps when called. Return set immutable prototype O V10 4 7 to set immutable prototype O V. The abstract operation set immutable prototype takes arguments O, an object, and V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O if same value, V, current, is true. Return true, return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create, table 34. Proxy handler methods. Internal method, handler method, get prototype of, set prototype of, is extensible, prevent extensions, get own property descriptor, define own property, has, get, set, delete property, own property keys, call, apply, construct, When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariance defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object. P is a property key value. V is any ECMAScript language value and desc is a property descriptor record. O for copyright sign. ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible. Target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of. If trap is undefined, then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false, return false. Let extensible target be. Is extensible. Target 0. If extensible target is true, return true 1. Let target proto be target 2. If same value, V, target proto, is false, throw a type error exception 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, get prototype of applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let boolean trap result be to boolean. call, trap, handler, target. Let target result be is extensible. Target. If Boolean trap result is not target result, throw a type error exception 0. Return Boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. If Boolean trap result is true, then a let extensible target be is extensible. Target. B if extensible target is true, throw a type error exception. Return Boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a Boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a Boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoked proxy O. Let target be O. 06. ECMA International 2024. 3. Let handler be EO. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target. P. 0. If trap result obj is undefined, then if target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be is extensible. Target. D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be is extensible. Target. 2. Let result desk be to property descriptor. Trap result obj. 3. Perform complete property descriptor. Result desk. 4. Let valid be as compatible property descriptor. Extensible target. Result desk. Target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p. Desk. The internal method of a proxy exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P, desk. Let desk obj be from property descriptor, desk. Let boolean trap result be to boolean. Call, trap, handler, target, P, desk obj. If bool and trap result is false, return false. 0. Let target desk be target. P, ECMA International 2024 207. 11. Let extensible target be. Is extensible target. 2. If desk has a field and desk is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desk is undefined, then A if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else A if is compatible property descriptor, extensible target, desk, target desk, is false, throw a type error exception. B if setting config false is true and target desk is true, throw a type error exception. C if is data descriptor, target desk, is true, target desk is false, and target desk is true. Then, I if desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable, unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable, unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desk be target. P. B if target desk is not undefined, then I if target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. Return boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as an own property Y of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false, then if is data descriptor, target desk, is true and target desk is false, then I if same value, trap result, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true and target desk. 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its. 0, 5, 9. The perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. handler, target, P, V, receiver. If Boolean trap result is false, return false. Let target desk be target, P, 0. If target desk is not undefined and target desk is false, then ECMA International 2024 209. If is data descriptor, target desk, is true and target desk is false, then I if same value, V, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true, then I if target desk 1. Return true. Note the result of capital C and not change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler, target, P. If boolean trap result is false, return false. Let target desk be target, P, 0. If target desk is undefined, return true, 1. If target desk is false, throw a type error exception, 2. Let extensible target be. Is extensible, target, 3. If extensible target is false, throw a type error exception, 4. Return true. Note for proxy objects enforces the following invariants. The result of is a Boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible. Target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key be if desk is not undefined and desk is false. Then, I append key to target non-configurable keys C else. I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariants. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let argArray be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. argArray. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let argArray be create array from list. Argum ents list. Let new obj be. Call. Trap. Handler. Target. argArray. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The result of must be an object. 0, 5, 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let p be make basic object. Set p's essential internal methods, except for and, to the definitions specified in 10.5. If is callable, target, is true, then a set p is specified in the 10th of May 2012. B if is constructor, target, is true, then I set p is specified in the 10th of May 2013. Set p to target, set p to handler, return p, 12. ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U+0000 to U+10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points, even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template L, iterals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write N instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let C1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 x d800. Let Q2 be the code unit whose numeric value is CP0 times 10,000, modulo 0 times 400 plus 0 x dc00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1 3 static semantics, UTF-16 surrogate pair to code point, lead, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments lead a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0 x d800. 0 times 400 plus trail 0 x dc00 plus 0 times 10,000. Return the code point CP. 1 4 static semantics. Code point at string position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then return the record CP 1 true. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point CP3. Return result 1, 1, 3 static semantics, UTF-16 surrogate pair to code point, lead, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments lead a code unit and trail a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0xd800. 0 times 400 plus trail 0xdc00 plus 0 times 10,000. Return the code point CP 1 1. For static semantics, code point at string position. The abstract operation code pointer takes arguments string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert. Position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If the first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1 full 6. If the first is a trailing surrogate or position plus 1 equals size, then return the record CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2 false 1 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position size. Let CP be code point at string position. Be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 111. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code point, S, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is passed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, C10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text match by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors parse might report the syntax error and not proceed to the early errors parse. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024-215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions. 15.2, arrow function definitions. 15.3, method definitions. 15.4, generator function definitions. 15.5, async function definitions. 15.8, async generator function definitions. 15.6, and async arrow functions. 15.9. Function code is also derived from the arguments to the function constructor 202.1.1, the generator function constructor 273.1.1, and the async function constructor 277.1.1. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1. 2. 1 directive prologues and the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1. 2. 2 strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4. 3. 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive, function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign. ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use-strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use-strict directive and which does not have a meaning defined by the implementation. 1. 2. 3 non-ECMAScript functions. An ECMAScript implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMAScript source text. Whether a function object is defined with an ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2. ECMAScript language. Lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element #bang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following. App equals b high g exec, C map, D, where the first non-white space, non-comment code point after a line terminator is u plus 002 f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as app equals b high g exec, C map, D, syntax, input element div, white space, line terminator comment token div punctuator right brace punctuator, input element regexp, white space, line terminator comment token right brace punctuator regular expression literal. ECMA International 2024 217, capital I, N, P, U T capital E L E M E N T capital R E G capital E X P capital O R capital T E M P L A T E capital T A white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white space, line terminator comment token div punctuated template substitution tail, input element hashbang or regexp, white space, line terminator comment token hashbang comment regular expression literal 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals, U plus 200C, 0 width non-joiner, and U plus 200D.
I'm done. I'm finally done. I finally figured out how to convert a define, an assign, whatever you want to call it, to a string, a fucking string that can be printed as a number. Look at that. That took so long to get working. Oh my god. Holy shit. That was ridiculous. So, you make an assign. You start at 0. Then this assign gets assigned to itself plus 1. In the documentation says that when it's an assign, it gets turned into a literal number. Now, you can use string on the assign, but then it's a token, and you can't glue a token. But somehow, you can make a token, not as a string, into defined string. But you can't. Holy crap, that sucked. Chatbot is garbage. I can't get any of that time back. That took so long. Fuck. So, where's the time?
White space.
There has to be a better way. I swear to God, it used to work. You go like this or something,
Value. They may also occur within
and it would just work.
any other kind of token.
Or something like that.
Space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation.
This works though.
009. Character.
I'm just gonna leave it like this. This works. Whatever this does is working. I had to look up the mother loving documentation
ZWNB.
because chatbot is a joke. This is not gonna take anyone's job. I kept saying
Part of OSP syntax. Note 2. Other than for the code points listed in Table 36, ECMAScript white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. Zs. 2.3 white space tab VT FF ZWMBSP.
I don't know. Here's what chatbot said. I got nowhere closer to solution. Chatbot should have said, use fucking the string function.
However, unlike white space,
Because it's real obvious that it has something to do with the goddamn string. But it didn't. Instead, it kept saying like, put it in tick marks, and that'll make it concat. Because NASM will like look at it and evaluate it as being a token. That's not even true. Where the fuck did it get that idea? That's not even how it works. That took so long.
This cannot occur.
I'm gonna die. Just kidding. I feel so alive. I'm so fucking tired.
Occur within a single line
It's freaking bullshit.
by the S.
I just wanted to print the number. So like, I think I'm done for now. I've had it.
Are listed in table 37. Table 37. Line terminator code points. Code point. Unicode.
And like, this works, whatever.
U plus 0.
When you make it string or whatever.
U plus 000 D. Carriage returns.
So you have to like define string, give it a name, and you define it as string using the string function.
Points in table 37 are treated as line terminators.
But when you use the string function,
Code points are not treated as line terminators but are treated as white space if they meet the requirements listed in table 36. The sequence CR LF
it adds parentheses to the numbers.
syntax
I was gonna give up and be like, that's good enough. But then I realized
line terminator sequence LF
somehow I can just pass it in like that as the literal assignment that it is.
multi-line comments cannot net.
But somehow that didn't work. I swear I tried this before and it wasn't working, but now it's working.
And because of the general rule that
Or maybe it worked, but it looked like it glued them all together because I didn't have a parenthesis, comma, so I didn't notice that it was working.
terminator at the end of the line is not
But now it prints
consent.
just the number.
The lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that
The chatbot was so useless.
automatic semicolon insertion C12.10 comments behave like white space and a Apple Silicon PC, Google Search, NASM Macro, Fine Issue, Compiler Explorer, Why is Siri talking slowly? Recently, Siri has started talking slow and low. I can't glue to a string the percent macro archive. How do I glue the %1 to a string? You're absolutely right to be puzzled. Gluing %+ or quoting macro parameters like %1 into strings or labels in NASM isn't always intuitive, so let's break it down.
This whole time, it kept repeating the same thing over and over and never got anywhere closer. And even when I gave it the string function asking it, it couldn't even work with that. This thing is a piece of shit.
Bullseye goal: you want to pass a macro name. For example, my macro as %1 into another macro and call it like my macro I or concatenate it like message %+ %1. Brain. Key rule in NASM. %+ is for token pasting. For example, label %+ I label 0 is for stringizing. For example, I0. Macro parameters like %1 cannot be pasted directly to strings using %+ because %+ expects tokens, not string fragments. Tick. Working solution. Indirection via %1 %I instead of trying to do.
This is not a working solution. Chatbot's lying.
You pass the argument into a macro, and that macro does the pasting. Hammer and spanner. Step-by-step example 1. Worker macro does the formatting. %macro string entry 1 msg %plus %1 db item %1 0 int macro. Passing a macro name %1 to another macro.
Whenever it says to pass a macro into another macro to solve a macro, that's a problem in itself.
Tick, tick, tick. Use %. For token, %. Label %1. Tick. Example. Use with %define. This still makes a define label. IT needs to be text so IT can be part of SDB. Fire. Got it. You're not asking for a label, and not a %define, and not a stringified token name. You're asking to turn a macro argument like %1 into text, so you can embed it as part of a DB directive, a real string in output, not a label, not a macro call, not a stringified number.
Yeah, but still couldn't solve it.
You're saying, I want to generate a string at assembly time like my macro name from %1 inside %macro emit string 1 db the, but this fails. So here's the actual working solution.
This doesn't work.
Use the backtick syntax, but wrap the whole thing in quotes to make it valid for DB.
There is no backtick syntax. Where did it even get that from? Oh my god, chatbot is so stupid. Where did it get the backtick syntax? It doesn't exist. This is online documentation. That's backtick. It shows up 0 times. This is a PDF of the documentation. I'm gonna look for a backtick. It shows up 0 times. Where the hell did chatbot invent?
The backtick syntax.
How did chatbot come up with a solution? Just make something up out of fucking thin air? Oh, that was a waste of time. So, I'm done for now. I'm gonna let the stream run on for 10 minutes. I didn't get the macro done, because that's how the real world operates, and this is real-time coding. This is just like every other stream. Eventually, I'm gonna get to like running speed tests and comparing assembly language, comparing Microsoft Visual Studio against Clang, against my assembly. Eventually, I'll get to the standards. And then eventually, I'll get to the instruction tables, and I'll be able to test the MMX, SSE, SMD instruction stuff. Eventually, I'm gonna get there. But the last however many hours, I've been trying, and I have succeeded. I've fucking succeeded. At doing what chatbot, the artificial intelligence, is unable to do. I fucking got a loop in NASM, and I figured out how to fucking print the number as a goddamn string. So that's the end of the stream. Hopefully, I get further tomorrow. I'm gonna let the stream run on for 10 more minutes because it's this is modern streaming software. It doesn't always send the whole stream. So I'm gonna let the stream run on. Hopefully it'll all send. Peace. Chatbot sucks. And Windows is shit. Anyways, I'm done for now.
Not appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as n or u000 2 9 4 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text match by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2 9 4 to static semantics. SV, the syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1 2 9 3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, LS, is the string value consisting of the code unit 0 times 2028 line separator. The SV of double string character, PS, is the string value consisting of the code unit 0 times 2029 paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, LS, is the string value consisting of the code unit 0 times 2028 line separator. The SV of single string character, PS, is the string value consisting of the code unit 0 times 2029 paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000 Null. The SV of character escape sequence. Single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to Table 38. Note to it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, foo function invalid. 7. Use strict. 32. Copyright sign. ECMA International 2024. Table 38. String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B 0 times 0008. Backspace BS T 0 times 0009. Character tabulation. HT N 0 times 000 line feed. LF V 0 times 000B line tabulation. VT F 0 times 000C form feed. FF R 0 times 000D carriage return CR double quote 0 times 0022 quotation mark apostrophe 0 times 0027 apostrophe backslash 0 times 005C reverse solidus comma the SV of non-escape character, source character but not one of escape character or line terminator as the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence. Legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence. 8 is the string value consisting of the code unit 0 times 0038, digit 8, the SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0 times 0039, digit 9, the SV of hex escape sequence. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4. 3 static semantics. MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82. Times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6, the MV of 4 to 7. 7 is 7, the MV of hex escape sequence. Hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit, plus 0 times 100 the MV of the second hex digit plus 0 times 10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMAScript regular expression grammar. 2.2.2.1. An implementation may extend the ECMAScript regular expression grammar defined in 2.2.2.1. but it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminator but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, regular expression char, regular expression non-terminator but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E,